Yeah, Pooh, let's start.
Yeah, I hope I'm audible.
Yes, yes, you are audible.
Yeah. Hey guys, very good morning. Thank you for joining us. Let's on a Sunday morning. We will, as Shailesh explained, let's say for the next couple of hours, we will now start going deeper into the entire topic of eval. That like what are evals, why do we need, etc. So without further ado, let's quickly start. Okay. Uh, Now, I think since all of you would be, let's say, working closely in the domain of either product management or, let's say, working closely associated with the charters which are impacted by technology, I think all of you would have heard the term that, like, so, okay, vibe coding is coming into place nowadays. Building something has become a lot easier, lot easier. And hence, it does not take, let's say, more than a weekend to create something. But you might have also noticed, or at least, let's say, heard around in your circles that if you build something, to make it reliable is what basically takes a lot of time because the building is, let's say, not more a constraint anyway, but let's say making it reliable is basically what kind of becoming, let's say, very difficult. So let's understand probably with the help of an example that let's say you're creating, let's say, an AI chatbot similar to what Amazon has created for their website, let's say, which is Rufus. And this chatbot is supposed to kind of be an interface across the entire app, and you are doing, and it is supposed to cover all of the customer queries, like which could be either related to services, could be related to products, could be related to, let's say, shopping queries also. Now, once you have created this kind of a, let's say, shopping bot for you, when you're launching it for the very first day, you're shipping it to like approximately 10% of the users. Everything seems to be working fine. The product is exactly behaving the way you envisioned it to, and you are thinking that, let's say, you created, let's say, a great product, like which is not breaking. But the moment, let's say, the day 10 starts, right, there are certain kind of hallucinations that you start seeing into the product. Somebody is, let's say, asking for a specific product which is not even available, let's say, on the shopping website. The AI shop bot is going leaps and bounds and trying to fetch products which is not even posted on your website. And you've also seen, let's say, a lot of customers trying to kind of jailbreak the prompt, etc. So and trying to basically harm your AI system. Now, let's understand that, let's say, why this could actually be happening because so far, the way we have programmed ourselves is that, like, say, when we create any new product or any new feature, the feature goes through, let's say, an entire software development life cycle. So where what you do is that, like, say, first you write a PRD, then you kind of gather the requirements. After gathering the requirements from different business stakeholders, then you groom it, let's say, with your engineering, and engineering kind of creates a feature around the expectations that you have shared as part of either your spec or PRD. And then, let's say, a QA happens on top of that, like where you just try to ensure that, like, okay, if I intended the workflow to happen in a certain manner, which is ABC, is it even following that path, or there are certain deviations that I'm actually noticing? Now, this is, let's say, a traditional software development lifecycle practice that we had, and this QA is a function. Let's start focusing on it a little bit more. So when you talk about, let's say, this QA as a function, what is happening here is that, say, whatever actions that your product was supposed to get, right? So let's say if you're trying to build a product and you had the product works like following that, like it takes certain user inputs into consideration, it kind of processes them, and it is supposed to kind of generate certain user outputs. So in such cases, let's say what happens is that, say, by the very nature of the product itself, you have made a lot of user actions predictable. And what do I mean by that? Like, say, we will just quickly cover an example. And for this limited set of user interactions, what you have done is that, like, you have also directly mapped that, like, say, okay, for a given input, how does the output looks like? So let's take the example of a simple internet banking login flow that I think all of us would have gone through. The flow actually goes like following, or say, let me first define the scope or say the lay of the land, like what feature that we are building. So it's a simple internet banking login, and we are not trying to cover the entire breadth of the scope of internet banking. Rather, we are just focusing upon the login flow. Where what is expected is that, let's say, if a genuine user is coming onto the platform, he will have a pair of keys, like which is nothing but the username and password. And once we have that pair available with him, and if he enters the right combination of, let's say, input and output, like say we are going to allow the user to access the and internet banking portal. And in case he does not have the right pair, we will probably allow, let's say, some retries and then block the entire access to that internet banking portal itself, right? So now first let's come to the user input part, right? So by the very definition, you have defined the user input, let's say, very clearly that, like, okay, there has to be, let's say, a login ID, and there has to be, let's say, a password. And with this kind of a input combination fixation, you have also defined that, okay, what are the output scenarios that you're looking like? The first thing would be that, like, okay, if I enter something successfully, which is the first scenario, you allow the login to happen and the user can access the records, the bank records of his or her own. In case the user is not trying to enter the right login ID and password pair, you fail the login. And if there are certain number of retries which are remaining, you allow the user to go through those number of retries. And the third case that, like, when a user is trying to enter the wrong login ID and password pair multiple number of times, and if the user has exhausted the number of login attempts that he has, we kind of fail the login and we kind of log the account, let's say, to a temporary basis. So this was how the traditional products look like, and why the very nature of the products ensured that, let's say, when you're looking to do some kind of a product development, in the QA phase, you're able to understand and account for most of the issues, most of the bugs, so that when it goes out to the audience, it is perfectly perfect. Okay. I'll take a pause here before moving to the next slide. If there are any questions, happy to answer at this point in time. Okay, I'll take it to no. So let's go to the next, the present world that, like, we are living in, right? So I think all of us would have used the frontier LLMs in some shape and form in our daily or say work life. Now the very nature of this AI systems that we're building, because they are trying to use, let's say, a lot of LLMs, like, who are either generating things for you or who are either coordinating things for you. The very nature of LLMs govern that, like, they are very non-deterministic in nature. And anything which is non-deterministic is something which becomes, let's say, very, very non-reliable also. So let's take a very, very simple example, right? I think all of us would have heard this word that, like, okay, LLMs tends to hallucinate. So even if you ask a very, very simple basic question that, okay, what are the number of A's in a simple word, which is banana? It is likely that, like, out of 100 times, 99 times you get the right answer, but the 100th time you might not get the right answer, right? And this is the very non-deterministic nature of LLMs, what makes them non-reliable and unpredictable. Let's try to understand this topic of non-determinism, let's say, with the help of an example. I would like to take you, let's say, about a year back when India was playing a test match with South Africa in the Indian subcontinent itself. And the test match was scheduled to happen, let's say, in Guwahati, right? Now, there were a lot of articles going around, let's say, on different cricketing websites. Let's say you have found a article, let's say, on ESPN Cricket, and you're building a product that, like, okay, whatever news which is there around cricket, you will just try and basically summarize them and create an in-short version of it that, like, somebody will be able to just access or assess those news, let's say, in a moment of in just probably, let's say, a paragraph or less than 10 sentences, right? So what essentially you're trying to do is that, like, you're trying to create a text summarization tool around the fact that, like, okay, for sports enthusiasts, let's say, how do I create this text summarization tool? So you're also looking to kind of summarize these articles which are published in cricinfo.com. Let me give you some more context so that, like, you're able to understand this example really well, right? So what was happening in this test match is that, say, there was like a special geographical situation, and because of which there was early sunset which was expected to happen in Guwahati. And what was happening before that, because of that, is that like, in a typical test match schedule, like, which is a 3-session kind of a play, typically lunch happens first, followed by, let's say, tea sessions. But in this specific case, it was decided that, like, first tea will happen followed by a lunch. Now, it was, let's say, probably a one-page full article which was there on a ESPN Cricket. And let's say if you start putting it in your text summarization tool. Now, what might happen is that, like, you'll actually start getting two outputs. And before getting into the outputs, like, which you are which you will get out of, let's say, your summarization tool, let's also understand that, like, okay, if you were to take your QA head on, and if you were to understand that, like, okay, does this response even make sense or not? What will the rubric look like? So any summarization that is coming out of this article should basically contain multiple things clearly called out, right? That there's a test match which is happening in, let's say, Guwahati, and there's a specific condition because of which sunset is going to happen early, and because of that, the schedule of test match is having a change where tea will happen first, followed by the lunch. Now, with this rubric in mind, just try to read out these two summarizations that you're going to that you're getting, right? Which is the Guwahati test will have tea before lunch due to early sunset. Does it follow or does it pass as per the rubric conditions? Yes, because it is mentioning the Guwahati test. It is also mentioning that there's a specific situation of sunset happening early. And because of that, there's, let's say, a change in the schedule of the test match and where tea will happen followed by the lunch. The second thing is that what is happening is that, say, the second summarization reads like following: that early sunsets prompt a tea before lunch schedule for the Buhari test, right? Again, you put the lens of your rubric here and understand that like whether it makes sense. Yes, it does make sense because it talks about the Buhari test. It talks about a specific situation where early sunset is expected to happen. And it also talks about a situation where tea is supposed to happen lunch because of this change in the sunset schedule that we are going to observe. Now, when trying to look at it, right, I think all of us agree that like for a given input, which was this espncricinfo.com article, the output that we have gotten, which is the two bits of summarization, right? None of them seems to be incorrect because like we have, before even looking at them, we've defined the rubrics. And as per the rubrics, the summarization output looks completely good, right? So what the point that we are trying to drive here is that for a single input, there could be multiple right output combinations. Hence, the overall thing that like what you are able to do in case of a bank internet banking login scenario, where for every input action pair you are able to define a clear output. This kind of a liberty is something like which goes out of place, and that is what it makes the entire evaluation of any kind of an AI system more and more difficult and more, let's say, different than like what we traditionally used to do. So I'll take a pause here. Let's see if there are any questions. Happy to answer before we dive into the next section of this entire session.
Hey, Apurv, good morning. Basically, so the output will be from the same model, or is it like a different model?
So it's the same model. So even let's say if you're creating a summarization tool, let's say where the heart of it is, let's say a Gemini 3.0 model,
Hmm,
even if you try and basically put the same input multiple times, or let's say different users are trying to put the same input at different time span of times, the output could be different.
I see, I see. Yeah, then it becomes super difficult.
Yeah, sure, correct.
Yeah, got it.
Sure. So guys, let me move to the next part, right? So I think then all of us are thinking that like, okay, we are trying to basically build an EA system and it is something like say which is very, very difficult to even understand and comprehend. But before just straightforwardly jumping into the fact that like, hey, I'm creating something which is AI and I need to kind of test that like how it is working. I think you should basically also step back and try and understand something which we basically call as a concept of capability and consistency. Right? Now, what does this concept actually means? Let's try to understand, let's say with the example. The point we drive to basically home is that say, and any kind of an AI system is not like a super system or a superpower, which will work, let's say, in all of the scenarios. So I think as builders, we should also be emphasizing on the fact that when I'm creating an AI system, uh, is it even good enough to generate the output also, or let's say I'm being, let's say, very untrue to myself and trying to basically set very, very false expectations. So what I'm meaning probably will be very clear, like say with this example. The first kind of a models or say AI system that we might build, let's say, into our lives are neither capable nor consistent, right? Now, what do I mean by the term which is capable and consistent? Let's say if I were to kind of do, let's say if I were to kind of create a system where at the heart of it, let's say where at the heart of the AI system, I have plugged in a sentiment detection model, right? Now, this is an ML model. What does it do is that, let's say if you put in, let's say a piece of text, or let's say if you put in a piece of text, it basically helps you understand that like, okay, whether the user is happy or sad or angry or things like that, right? Now, in this kind of an AI system, you're trying to basically plug in, let's say, a very complex mathematical problem and asking it to say that like, hey, this is, let's say, a very difficult algebraic equation for me. Can you please go and solve it for me, right? Now, since you have not even created that concept of capability inside your model and you're asking a sentiment detection model to solve a complex mathematical problems, no matter how many number of tries that you're going to give, every try is going to give you, let's say, a wrong answer itself. So this is like a model where it is not just a question of consistency. And for consistency, I just want to drive myself back to the point where we were just trying to where we were just trying to solve a very simple question that like, what are the number of A's in banana? 99 terms, the answer was coming correct, but one time the answer was not coming correct, right? Here, even if you try 100 times, we can bet on this model that like 100 times the answer is going to be incorrect because it is not even a question of inconsistency. It is a question of capability itself. We have not even made our AI system capable enough. And hence, for all of such cases, right, there is no need to even go to any kind of a QA layer that you would actually have later in the other cases because it's like just a wastage of, let's say, your bandwidth. It's a wastage of, let's say, your mind share. I'll go to the next part, right? Where let's talk about something, let's say, where the model is capable but not consistent, right? So again, let's try and plug in the shopping boat example with which we have started our session altogether. In the AI system, let's say we have created or say we have plugged in an AI powered chatbot. Simply putting, let's say you have taken a very advanced frontier lab model, let's say a Gemini 3.1, or let's say maybe even a Opus 4.6, and you have grounded this particular model in the knowledge of your organization. Let's say if you're working for any kind of a D2C brand, you have completely made aware the model that like what the D2C brand is, like say what are the different policies, what are the different queries that could actually come. Now in this kind of a chatbot, let's say if a customer query comes, it might so happen that like out of the 10 times, 7 times the answer is coming correct, but there are 3 times where because of hallucinations, etc., the answer is actually not correct, right? So this is like a system where we will say that like, okay, my system is capable because I have equipped it with the right set of tools, with the right set of, let's say, uh, guardrails. But because of the very nature of non-deterministic, like say, I feel that like it is not consistent at times. And hence these are the things that like we should start focusing upon, not the first criteria, not the first kind of AI systems that we have talked about, right? Now, I think you would also want to understand like, okay, this looks very good to explain, let's say it in plain English, right? But is there any kind of a numerical, metrical way to even land this concept to somebody that like, okay, I'm trying to build that like, how do I differentiate between capability and consistency? Yes, there are ways to define this entire concept mathematically. So we will look at two metrics, right? First, which is something called as pass escape. Now, what this basically means is that this is kind of a very lenient metric. What it says is that like if you enter or if you take a number of tries, what is the probability that at least one time your AI system was able to, let's say, give the right output? So to simply put, let's say you have taken an AI system, and again, I'll go back to the example. You have done basically 5 tries. Now, in all of the 5 tries, you are basically going to get the wrong answer. Hence, the value of pass at k for this specific kind of a model becomes, let's say, you call it, let's say 0. Now let's come back to this specific model where you have, let's say, an AI system where you have an AI powered chatbot. Now, out of 5 tries, you are basically getting the right answer 2 number of times. Okay, so still, let's say the probability of you getting the right answer at least 1 times becomes 1. So the pass at k for this particular model becomes 1. Now let's talk about something called as reliable at k. This is, let's say, slightly more stricter metric, which will kind of highlight the gap between capability and consistency. What this metric typically tells is that, let's say if I have done 5 number of tries, right? What are the number of times I did get the right answer? So again, I'm going back to the same example before. In case of this, neither capable nor consistent kind of a model, your pass at k value was 0. And since in none of the times you're going to get the right answer, your reliable at k also becomes 0. So ideally, if you try and subtract it, like which is pass at 0, is same as reliable at 0. That means the model is, there's no gap between capability and consistency, right? Which could either mean only two things: that you've built, let's say, a perfectly good, let's say, AI system. But the moment you start looking at the value of pass at k, which is 0, you can start truly understanding that like, okay, I've created a system which is not capable, and hence there's no question of consistency that I should even have, let's say, in my mind. Now, let's try to apply the same lens of reliable at k, let's say, on the different kind of a system where we have an AI system and we have an AI powered chat. In the same example that we explained, out of 5 times, 2 times you are supposed to get the right answer. Hence, the value of, let's say, reliability at 5 for this specific kind of instance becomes 0.4, right? Now, the gap between the pass at k and reliable at k. So earlier in the very first step, we also determined the pass at k value for the second kind of a system. The value was coming out to be 1. And in this case, the value is something which is coming out to be 0.4, because out of 5 tries, you are only able to create a successful output only 2 number of times. So this gap between pass at k and reliable at k is what typically helps you understand that like, okay, what is the gap between my capability and consistency? This is, let's say, a very uh, nuanced way of putting that, like whether your AI systems are even capable, or if they are capable, how consistent they are. So this is, let's say, a very important concept that you can keep in mind when you're trying to create any kind of an AI system. I'll take a pause here before moving on. If there are any questions, happy to answer.
Hi,
I'll
sir.
take
Good
it.
morning. I have a small question. If you
Yeah,
can go back to the previous slide, I had a question on that.
sure.
So in the first example, sentiment detection model, let's say instead of passing a complex mathematical problem, we are just passing a text and asking the system to find out the sentiment of the
Yeah,
text.
yeah,
Can we
yeah.
call that capable and consistent then?
Yes, because I think the over point that like you have to come across is that like say what kind of use case that you're trying to solve for. Let's say if your entire use case was to solve mathematical problems, and if you're putting a sentiment detection model at the heart of it, it is neither going to be capable nor going to be consistent because you've taken a wrong choice of the model in the very first place. But if you flip the question and say that like, okay, my entire setting itself is to find uh to detect the sentiments of the users, and if you put this kind of a model, it will start falling in the second category.
Okay, so that is deterministic. That's what we call it.
Not deterministic always, right? So still there are chances that like where you'll start getting so that there could be let's say certain hallucinations, or you have not let's say programmed your AI system correctly. So still you might actually face some kind of let's say hallucinations, etc. So it might not be let's say 100% deterministic, but it will at least start becoming let's say capable. So it was not capable earlier, but it will start becoming capable now.
Understood. Yeah.
Yeah.
Thank you.
Okay. So now let's, I think, come to a very, I think, important topic with, I think all of us have made this mistake. Let's be very honest, right? So all of us have actually made this mistake that whenever, let's say, we are creating an AI system, and I think somewhere we also understood that like maybe a traditional QA is not the right way to solve it. What we were actually doing is that like say we created the application in the very first time, and then we tried to run it through a few use cases, understood that like say how's the response coming light, and let's call them as let's say vibe checks. And if we feel that like, okay, the entire AI system is kind of slipping at places, we go and kind of figure out that like what those gaps are. Let's say maybe it requires a fix in the prompting, or let's say maybe a fix, maybe it requires, let's say, a fix in the data in which I'm trying to ground this AI model. And once we do that, let's say we kind of do a modification and then try and basically run this exercise again and again, right? So this is like an iteration loop that you can actually run. I'm not saying that like it is a wrong way of solving the problem. It is not the wrong way of solving the problem. But the only thing that like we want to kind of drive home here is that like this is something like which is good for the initial vibe check. But this entire thing for you to kind of test your AI system is something which is not scalable. Hence, what we need is that say whenever we are dealing with any kind of an AI system, we want a proper evaluation system to measure the consistency of our AI systems. And this is, let's say, what brings us to the topic of eval. So let's understand that like what eval is. Again, like this is like a very academic definition that we are going to talk about. Going forward in the session, like we will also try and understand that like how this definition folds up in different cases itself. But purely from a textbook definition, an eval is nothing but a short form for evaluation. And it is a structured test to check the performance of an AI system. It helps the system owner measure the quality, the reliability, and correctness across different scenarios, right? So again, like this is a definition which you can keep in mind. Throughout the session, we will try to learn more that like, that what are the nuances of this definition. And if you were to create an eval, how would you go about, let's say, in the practical scenario? Again, this is, let's say, a very important slide, and I want all of us to kind of focus upon seeing, right? Now, I think one thing which is also happening around the world is that say all of this intelligence is available so freely to us because there's a lot of players which are out there in the market who are trying to grab their attention, and a lot of the intelligence which is available to us is available at a subsidized rate because right now I think there are multiple players who are trying to win this market, and hence there's a very natural instinct in all of us that like, okay, if I haven't created an AI system, let me also see that like how AI itself can solve that AI system of my own, right? But this is, let's say, where most of the people actually starts making a mistake, and hence let's try and first understand that like say what are the different type of evals which are available, and in what kind of a setting what eval is something like which is necessary. Okay. So the first topic that like we want to highlight is something called as, let's say, a code-based eval, right? Now, what this code-based evals is that say, let's say it's a simple deterministic rule for output evaluation. And when do you use it is that, let's say when your evaluation criteria itself is, let's say, very deterministic in nature. Right? So let's say you are creating you're creating an AI system, right? Let's say it's a recommendation system for say, and the output comes in a certain way, right? And because that like you want that output to be consumed by one of the downstream system of yours, you want the output to be in a very specific format. Let's say after discussion with your engineering, you said that like, okay, JSON format is the right format in which this output should come. So again, detecting that like whether a piece of a output which is coming out of LLM is in JSON or not is a very deterministic problem. Second thing could be that like, again, let's say I'm going back to the InShorts example, where you're trying to, let's say, create a summary for the sports article. And because of the available real estate space on the user's mobile applications, you want this entire summarization to happen, let's say, under 100 words. Now, this character counting is also something which is very deterministic, right? That like when an output comes out of an LLM model, you simply count the characters, you simply count the words and say like whether it is yes, whether it is good or not, right? So in such cases, but the output is very deterministic and the problem is something which can be solved using a rule, etc. You take help of something called as a code-based evals. So in your, let's say, entire AI system itself, once the output comes, you can actually keep a loop that, okay, check if the number of words of the output are lesser than 100. If yes, then pass it on to the next system. If not, then try and basically regenerate it, specifically instructing the LLM that like, hey, I tried to keep this under 100 words and you try to generate, let's say, more than 100 words. So this is something, let's say, which is very simple and called as code-based evals, which is used for, let's say, deterministic problems. Now, some of the problems could be slightly non-deterministic also, but the question arises is that like for every non-deterministic problem, will I start using, let's say, any kind of advanced LLMs or what I think people around are talking about, right? The answer is no. You should also try and look at that like what kind of non-deterministic problem that you're dealing with, right? Again, if the nature of the non-deterministic problem is something which has been solved in the past and it is solved adequately well by other people using the external data, and it is also available, let's say, as some kind of, off-the-shelf ML model available to you, start choosing them. So some of the things could be that, let's say, if in a piece of text, you have to identify the sentiment, which is again a very non-deterministic kind of a problem. Or if you have to identify that, like if you're generating something, does it contain PII? PII is nothing but any kind of a personal information identifier, could be, let's say, name, age, address, etc. Then you can actually use an off-the-shelf model. And how do we use it is something that like we'll cover in the demo towards the last part of towards the end of this session. Then comes to the third part, right? Where we start basically using an LLM as judge, and probably this is something that like you would have heard, let's say, across your circles of different people talking about it. But this is, let's say, a most complex or most evolved set of events that we can build, and we should only use it, like say A, when the nature of the problem is very non-deterministic, and second, the problem is also something which is non-generic and something which has not been solved or which cannot be solved by any off-the-shelf ML model which is available. Now let's spend some time to understand that, okay, what these problems actually are, right? So I think let's take a step back. I think all of us would have uh, observed so far that like LLMs tends to be very, very helpful. Even if they do not know the right answer, they will make us believe that like, okay, I know the right answer, and this is where they start hallucinating it, right? So the first use case that where LLM as judge could start coming handy are basically handoff issues. So what typically happens is that, let's say, again, I'm going back to the example of the shopping board that we have used. You are trying to basically create a system where a customer is trying to interact with the shopping bot, and the interaction has already crossed, let's say, 10 to 15 messages. Now the customer is very irritated and customer wants the problem to be handled by, let's say, a human, purely because of the fact that like either the machine is not able to understand the human sentiments well, or you have not even covered, let's say, this use case very well enough, let's say, into your AI systems. Now, what might so happen is that at times the AI system is supposed to understand that like, okay, I'm not able to satisfy the human response, and hence hand off the entire conversation to a human, like which could be like say an end to layer in the entire resolution journey. But it might not do so in certain cases, right? So whenever certain kind of let's say shopping bots are running into your ecosystem, to understand that like if a problem is a handoff related problem or not, you start kind of use LLM as judge. The second thing which could actually come is something called as out of scope answers. Imagine that, let's say, this Apollo hospital, right? Like which is really big. And Apollo hospital has, let's say, built some kind of a chatbot, let's say on their website, which is supposed to address the simple customer queries that like, okay, whether a doctor is available also or not, like how do I kind of do an appointment or whether parking space is available or not. So ideally, by the very legal law, this chatbot is not supposed to kind of give any kind of a medical advice, right? And hence you would want to kind of keep a very, very strong check on that. But again, as the very nature of LLMs, it might so happen that like it starts kind of giving any kind of a medical advice. So the out of scope answer that like even if somebody on this Apollo hospital ka website asks a question which requires a prescription or any kind of a medical advice, to understand like if the model is even going to give that particular advice or not, we can actually use something which is LLM as judge, because the problem here is something which is non-deterministic and very non-generic as well. So these are the three broad category of evals that you can actually create and use. And I think by now, at least from the problem lens perspective, at least now you would have some framework in mind that like, okay, when do I use what kind of an eval? And all of the three specific evals is something that like we'll try and basically build together, let's say towards the end of the session in form of a demo. Now, let's say as a builder, right? When you're taking this decision that like, okay, what kind of eval should I even create for what kind of a problem? Just like have a very simple rule in your mind, right? You should not try and basically use a very complex and a costly solution for a simple task, because at the end of the day, the evaluation is also something like which is a cost intensive exercise. And whatever cost that you're going to incur to kind of evaluate your AI systems are going to be part of your balance sheet and going to be part of your P&L statement itself. So you should be very cautious about it, like say how I'm going to spend that money. And in terms of cost, typically code-based evals are the cheapest, followed by off-the-shelf models. I don't think there's a lot of difference between the code and the off-the-shelf model, but still like this is the order. And LLM just tends to be the most expensive solutions when you're, let's say, trying to create any kind of an AI eval system. We can also, let's say, put this entire thing and put this entire framework, let's say, in a 2x2 kind of a matrix. And I think this is like a simple framework that you can keep in mind. If you try to, let's say, plot the cost that you have to incur for the evaluation and the effort which is required to kind of do an evaluation on the x-axis, and if you were to plot the complexity of the evaluation on the y-axis, and if you try to understand that, like, okay, how do I pair? The left bottom quadrant that you can see is something which is the right fit for code-based evals. Why? Because the cost which is required to kind of even generate this eval is something, let's say, which is very, very low, and same is the effort. And the problem that you're also trying to solve is not very, very complex. Higher up the order, let's say if the cost and effort are still not so high, but the complexity of the problem increases, you start using off-the-shelf ML models that you have, right? And the third case is that where both the cost and effort and the depth of evaluation required kind of takes kind of takes a orbital shift and becomes very, very high order problems. This is where you basically start invoking LLM as judge, right? So if something requires you to just kind of solve a very deterministic problem, do not use an LLM as judge there. And I think all of the 3 and 4 cases, this is the use case that like we should be very cautious about. That if a problem ka, let's say, depth of evaluation is not very, very high, let's say if you have to just count the number of characters, do not spend a lot of money on, let's say, a very costly and very effort intensive solution. So do not, let's say, invoke an LLM to kind of count the number of characters in a sentence, because A, it is a very complex problem to solve. And B, by the very nature of LLM itself, it might so happen that it gets hallucinated, and out of, let's say, 100 times, it might actually give you response, negative response or the wrong response 2 number of times. So this is what we have learned so far, let's say in this specific session, is that like, okay, we have understood that like, what are the evals. We have also understood that like, say, what are the different type of evals. And we have also focused upon that in what kind of a situation, what eval to use. So I'll take a pause here. In case there are any questions, happy to answer. Otherwise, we can move to the next part.
Hi, sir. I do have a question.
Yeah.
So until now, we spoke about evaluating text-based outputs from LLM. What
Yeah.
about a case where you give a prompt and ask the LLM to give you an image? It's an image generation use case. What
Yeah.
kind of eval will be very suitable for that?
Yeah. So there I think we use a lot of multimodal evals, etc. That is something that we will not be discussing today, but just to give you an example of what it actually means is, right. So when, let's say, you're creating an image, right, there also you can actually have a lot of guidelines in place, right? Let's say you're trying to create a very simple solution where there's a let's say a can of, let's say, Coke which is written somewhere, and let's say I'm kind of standing in a different kind of a let's say setting altogether. And now what you want is that like you want to create a prompt that like, okay, make myself hold that can of, let's say, Coca-Cola, right? Now this could be, let's say, another output. Now once uh, the output comes out, again, say, let's say there will be various ways to kind of evaluate that, like whether it kind of distorted my face, distorted my image, whether the positioning of Coke can is correct or not. Let's say if the Coke contains the logo of Coca-Cola, like whether it is coming correct or not. So the very framework of how do you solve this kind of image related problem still remains the same, which we will learn throughout the, let's say, entire journey. But the very evaluation tools that you're going to use are going to slightly differ. There you will have to start using a lot of multimodal tools. I hope I answered your question.
Yes, understood.
So I have a question basically when we talk about evals cost, right? So yes, so say if I'm developing my application and then I'm evaluating that, right? And now I
Yeah.
feel that the model is stable.
Yeah.
Like can I stop the evaluation? Because now I know that, say, for a good 15, 20 days or 30 days, I've done the evaluation. And I don't want now that I don't want to incur the cost because the number of, it has been tested thoroughly. Just a thought.
Great question, I think, Ayush. And it depends, let's say, on a case-to-case basis. So there are multiple cases that like we've encountered, right? So let's say if you're trying to create some kind of an intelligence using your LLM's AI system, right? That like, okay, let's say probably these are the set of inputs, and for this set of inputs, let's say what are the right outputs, right? Now, once you create this intelligence is something which is going to get verified, let's say by humans, by different events, and you're going to, let's say, use it multiple times. And you have a use case that like you do not want to refresh the intelligence that you have in the very first place, right? Now, if this is the case, that becomes the exact case that you're talking about. That like, okay, I have created a system. I have validated it also once, and I'm satisfied, let's say, with the output. Now, since you're not even going to refresh this intelligence itself or the output of the AI system itself, there is no need for further evals, right? But if it is a continuous process, that let's say you're using this entire thing on a daily basis, let's say you have a pipeline where approximately 1,000 inputs or let's say 1,500 inputs are going through your AI systems. Even it so happened that like, okay, on the very first day when you're launching this product, you have created an eval and everything was working to be fine. On 100 days, there's a possibility that like, okay, I'll not even invest on evals anymore. Maybe the framework that you can keep in mind is that like, okay, earlier I was really stringent about it. And I was, let's say, checking all of the 100 outputs that I was generating every day. Maybe these going forward, let's say if I'm generating 100 outputs, I'll put my eval only on 10 because it's a cost. And I'm fairly confident that things are actually working fine. So again, depending upon the context, you can actually take a decision that like, okay, whether to make evaluation a continuous process or whether to make it a one-time process.
Got it. Another similar question actually is, so see, whenever we build any web app, right? So generally I'll write the PRD, right? In that I will tell also what are the things which I don't want my chatbot or something to answer, right? So
Yeah.
what I've seen generally a lot of time while building the application, it does take care of that, right? Outside that, it does not pass the boundary, right? Now, say if I started using Evals and I realize that people are asking this question, and this is where like LLMs are failing. Can I not create a repository of the same thing and then put it in my vibe coding, the code, and then it basically even make my things more stronger, and then I can stop it.
Hey, sorry, I lost the last part of the question. Sorry, my internet connection is slightly weaker. Can you please repeat it? The last part, I was able to understand that like, okay, you have a section in your PRD where you're writing the pass-fail criteria. After that, like your voice started breaking for me.
No problem, no problem. So basically, once that is done, right? So after that, say I put my code for evaluation, and then during evaluation, I also figure out that these are maybe some of the cases I might have missed it, and I have figured out the pattern, right? Pattern in the sense where my code is breaking. So I take that and then put it as an input again, and then I can stop the evaluation. See, the idea is like the cost. I know output is important, but at what cost? Because companies generally will not want it to spend too much on
Fair.
the.
I think Ayush, you can actually keep a pin on this. I think it's a very important concept what we will discuss in something called as during the trace analysis part of this session, where we will talk about the concept of, let's say, saturation. It is slightly subjective, but at least you will get a framework that like, okay, in such scenarios, like say, how should you even think about it?
Got it. Got it. Yeah.
Yeah. Okay.
So
let me.
I just have
Go
a
ahead.
quick follow-up question on Ayush's expanding on Ayush's question. So I want to understand like how do we select an eval set for an agent whose output is unknown to us? Basically, I have built like an internal chatbot and I don't have access to the output or what queries the users are asking to it. So I just have, the number of plugins that I have added in the agent, and I can basically infer a couple of questions from
Hey,
them.
sorry, Utkarsha, can you please be a little louder? Sorry, the last part of the sentence. I understand. I was able to gather till the agent part, like where the output is something which is not known.
Is it better now?
No, it's still very feeble for me. Shailesh, are you able to hear her?
No, no. So Utkarsha, your voice was very good like the start, but it is like it's not audible now.
Okay, give me A second. Is it better now?
Yes, yes, now it is better.
Yeah, sorry. So basically, the output is not something that we can see. Also, the input is also not something that we have access to.
Yeah.
So how do you evaluate like such an agent, like a chatbot agent, where we don't have control or access to the input and output?
Very good question, right? So I'll try and basically answer this question, let's say, into two parts, right? So I think in the very next slide, we are going to cover a topic where we will try and understand that, like, okay, how do I even understand that, like, what is the right answer? And will I even know that, like, every time, whether I'll have the understanding that, like, I know the right answer also or not, right? And second is, let's say, with respect to any kind of an agentic architecture that you have, right? So the kind of eval that you're going to use also depends upon different architectures, right? So since you're bringing this topic of architecture, I probably will jump the gun. That the very again, I'm jumping the gun here, guys. Sorry for the same, but the kind of eval suite that you have to use for agentic architecture is something which is very different. So you have to create something called a transition matrix, where you will first understand, like, okay, if agent has to take multiple steps, in what is the one step, like, which is failing, and then you try and basically understand deeper into the same, right? So maybe let's say we are not covering today the agentic architecture for evals, let's say in this specific session, but we are covering RAG. But to your question that, like, okay, how do I understand that, like, say, what is the right answer and how do I evaluate the same? I'll just tell you that, like, kindly just put a pin on this question for probably next 5 minutes or so. The next slide is going to talk about that.
Sure. Yeah.
Huh. So I think that the question, I think, which Utkarsha was also asking, right? That, like, okay, and I think from now onwards, the session that, like, we are going to take, we are going to steer it, let's say, more in the direction of that. If you have to create an LMS judge, like, say, how do you go about the same, right? I think the question that, like, now everybody will have in mind that, like, okay, how does my judge know that, like, what is the right answer, right? And like, whether my eval structure will also depend upon, like, say, if I know the right answer also or not. Yes, in industry wide, there are two terms which are called as basically reference based and reference free evals. Now, what is a reference based evals? Like, as the name suggests, so these evals are used, let's say, when you already have a reference for what does a good answer look like. So you already know that, like, okay, this is the task and this is the right answer for the same. Some of the examples could be that, let's say, if you were to generate, let's say, an SQL query or a piece of a code, it is basically counted, like, in the reference-based evals kind of an ecosystem. Now, the question which will come to your mind is that, like, okay, if I were to query something, there are multiple ways of writing the query, right? Now, again, let's say if you go back to the example of the Guwahati test summarization that we did, if there are multiple ways, how do I know, let's say, what is the right answer? So this is, let's say, one place where the confusion starts arriving, that, like, when we are looking at the reference-based evals, we are not looking at the way the query is written. Rather, we are focusing upon that, like, what is the right answer. Let's say if the query that you are writing is supposed to get that, like, okay, what is the monthly revenue of any company? That answer is just singular. Let's say it is $1 million, right? So every eval that, like, you're building, or say the answer that you're supposed to get is 1 million, no matter whatever query that you're writing. The second kind of an example which comes to mind here is something called as data extraction kind of an event. So let's say you have an annual report and you would want to, let's say, and you extract certain information out of it. Let's say you're trying to create a version of trend line where you say that, like, if you put any kind of an annual report, I'll help you understand that, like, what are the things, let's say, which kind of improve this quarter or decrease this quarter, right? So let's take the example of eternal itself. Now, all of the data that, like, you want to understand, or say you want to extract, is something, like, which is already there, like, in the very base document that you have, right? So it could be, let's say, the revenue of eternal, could be the number of dark stores that you've opened, etc. So in all of these cases, when you're trying to evaluate, like, whether AI system even work correctly or not, you already have some kind of an understanding, like, okay, what does the base answer looks like. The second kind of a eval that comes into picture is something called as reference evals. So this kind of an evals are used, let's say, when you do not even know that, like, what is the right answer, and it is very hard to fixate kind of a right answer. Maybe, let's say, it is known, but it is so wide, and let's say it is so elaborative that, like, it is difficult for a single person to even know, let's say, all of it. So one simple example that you can understand is that the different kind of synthesis task, like, say, which is happening by all of the LLMs, like, which could be either writing a blog or, let's say, writing an article. For these kind of a problems, let's say you basically use something called as a reference free eval. Now, the question might come is that, okay, whether I have any kind of a hybrid eval also or not, or, like, say, are these the reference and reference based evals the only two type of evals that I might encounter? The answer is yes. Hybrid free evals do exist. In fact, in many of the cases, you will come across the hybrid based evals only. So let's also understand that, like, what is one example? Let's say you have a contractual document for any kind of a legal entity, which is a 100-page document. Right? Now, what this document contains is like say a different scope of work and different kind of a project plan that like okay, when this should happen, if this should not happen, but what is the penalty limit, etc. So just focus upon the dates part that like this contract document contains multiple different kind of dates that are out there in the system, right? Now, if the AI system is asked to do that, like, okay, help me basically get the most important date from this argument, right? Now, this is from this particular document. Now, this is something like say where you partly know the answer and you partly do not even know the answer, right? How do you partly know the answer? That if you were to have, let's say, 50 different dates, let's say in the system, right? Now, whatever date that you're going to pick as the most important date has to be one among 50. If it tries to pick a date like which is not even part of the document, then it is like a wrong answer altogether. And in case the second part of it that like among the 50 dates, how do I figure out that what is the most important date? This is where you do not even know the answer. And the global intelligence of the LLMs or how you've instructed it to kind of perform the action starts coming into play. I'll take a pause here. If there are any questions.
Can you repeat the last part because of, I think, internet issue? Couldn't hear.
Sure, Ayush. So yeah. Am I audible now, Ayush?
Yes, yes.
Yeah. So Ayush, I think what we were kind of pondering upon the fact is that like, okay, we have understood what is a reference-based eval, what is a reference-free eval. What we are trying to answer here is that like, okay, is there a mixture of both? That which is like a part of it is reference-based, a part of it is something like which is reference-free. So you're trying to basically pick an example that like, okay, if you have a contractual document and if that particular legal document contains 50 different dates, and let's say your AI system is tasked to kind of figure out that like what is the most important date in the document. Now, all of these kind of a use case is something like which falls under the umbrella of a hybrid based evals, because the right answer that you're going to pick has to be one among the 50 dates, like where you already have a reference of 50 dates, let's say on your document. And the second part that like what is the most important date among all of it is something like which is subjective, where the output of it is something like which comes based upon the global intelligence of the LLM, or at least what are the instructions that you have provided this LLM to kind of get the response to. Okay, so this is, let's say, what is called as a hybrid evals, where both reference based and reference free starts coming into play. Cool. Okay, let's go to the next part. So when you're doing, let's say, any kind of an evaluation, and again, I'll just keep emphasizing on the fact that we are now going deeper into the understanding of LLM as judge. The first step is something which is basically called as a trace analysis, right? Now, I'm not sure, let's say, how many of you have heard this word, but trace is something that you can kind of understand that it is nothing but a systemic log of things that, okay, let's say if an action is actually performed, let's say if I give a task that go and summarize this article for me, it's an entire span of things that like, okay, how did the AI system go about it? Let's say, what are the steps that it has taken? And the entire log of what were the actions behind the scene is something which basically comes to us in form of a trace. And this is, let's say, what becomes a very important next point, where we start reading this trace and start understanding this trace to figure out that like, okay, if our AI system is even performing good also or not, right? So what is a simple example of a trace? Let's understand. So again, going back to the shopping bot example that like we have built at the start of the session, let's say we ask a question to the bot that, okay, what is the return policy for electronics? Okay. Now, once this question is actually triggered by the user, our system is actually going through multiple steps inside. And what steps does the system take inside is something like which is encapsulated, let's say, in a tree. So what it could actually do is that, okay, first it is trying to understand that like what is a user query. Now, what you basically get to also understand is that, like, say, what is the total latency that this particular trace has taken, right? So this gives you understanding that, like, okay, for the different queries, let's say, which are coming from a specific region, let's say a metro region in India, for the typical customer queries, let's say, what is the response time that I'm actually taking? This 2.47 seconds plus, let's say, any kind of a bandwidth time that you're going to take becomes your overall, let's say, response time, and gives you an understanding that like whether responding fast enough or let's say slow enough. The second thing, what it also does is that like it breaks the entire process of answering this question one by one, where you can also see that like in the very first step, the model or say the AI system is trying to understand that like, okay, what is the query? It is trying to kind of sanitize it. It is trying to kind of detect the language, etc. In the second case, let's say what it is trying to do, and again, I'm jumping the gun here, that like it is trying to first understand the question and trying to convert into some kind of an embedding space. Because most of this AI systems try to convert, let's say, any piece of a text into a numerical representations to understand it, like what does it mean. And then you also have fed this particular AI system multiple documents, like which contains your policies at a category level that, okay, for fashion, this is my return policy, for electronics, this is my return policy, etc., etc. So in this specific case also, like what it is basically doing is that it is trying to do a search among all of the documents that like, okay, if I were, let's say 100 different return policies, which return policies I should basically refer here. Now it is, once it is doing this exercise, like it has also figured out approximately, let's say 5 documents which are relevant for us to answer this question. And it is now taking these 5 documents, putting them, let's say in the prompt, creating a new prompt where it is trying to also answer, where it is trying to ask LLM that like, what is the question I asked by the user, along with the supporting data, which is the 5 documents. And then the final answer actually comes that like, what is the overall returns policy for electronics. Now, what is something that like you can actually understand here, right? So as a builder, you can understand that like what is the total response time, let's say, which is taken by the system. And then let's say if it comes out that it is a lot more than like what my competitor takes, or it is something that like I want to improvise upon, you have a step-by-step breakup that, okay, this step is taking this much of time. This step is actually taking this much of time. This step is actually taking this much of time, right? You can focus at like, okay, what is the possible areas of improvement, or say what is the possible thing which is taking the longest amount of time, and start attacking it to kind of improvise the overall experience of, let's say, of your product. The second thing that you can also do is that like you can also, let's say, understand that like what is the different amount of tokens which is consumed, let's say, by your AI system, because again, tokens comes at a cost. So you can look at, okay, for this specific action, this is consuming so many tokens. And now let's say after looking at multiple traces, you can also make up your mind that like, do I want to even optimize the tokens consumption in this specific space, or do not even have the room, right? So trace is simple, is nothing but, let's say, a log of the entire events like which are happening behind the stage for you to consume and understand that like, okay, how did the AI system even respond, and whether the response was even correct or not. Now we have looked at the overall structure of event. Let's also go through, we have looked at the overall structure of a trace. Let's also go through, let's say, some of the simple to medium to, let's say, very, very complex kind of a traces. Okay. The first thing that happens is that, okay, like a trace where the complexity level is something which is very, very low, right? So a user, again, I'll go to the same ESPN token, for example, again and again, that the user submits, let's say, a 500-word paragraph to be translated from French to English. Like in our case, it was, let's say, from a 1,000-page article to 1,000-word article to, let's say, a 100-word kind of an article. So the trace is very simple, that you got the translation request from the user. You check, let's say, if the user is kind of trying to translate any kind of a prohibitive or, let's say, abusive content. Like if it is not the case, you just, let's say, pass it on to LLM and ask it to kind of generate a summarization output of it, right? So it's a very simple example of a trace, because it's just, let's say, two-step input collected by the user, checking the sanity, and then like doing the translation altogether. The second part, let's say, where things might start becoming slightly more complex is an example that like we have seen as part of the opening slide of the specific section. Let's say if a user asks that, like, say, how do I reset my router, right? So the overall thing takes approximately 3.2 seconds. Again, let's say it goes to multiple 4 sets of steps, where first, when you try to convert this specific question, let's say, into some kind of an embedding, then you try to kind of retrieve the relevant documents, let's say from whatever policy documents that you have. Then you spend some time in prompt construction, and then you basically get to see the LLM generation output out of it. Right? The last part, again, let's say these are just sample examples, is that like where the complexity becomes even higher. Let's say if it's an agentic kind of an architecture, where a user is asking that like book me a flight to Bombay and a hotel under a certain budget, and the hotel should be, let's say, near Bandra. So again, the overall, what you can see is that like the first action that we tried to do took approximately 800 milliseconds, but as the complexity increases, you can also see that like the overall time which is required to even furnish this request starts increasing. From 800 milliseconds, it actually becomes approximately 12 seconds. And what is actually happening is that some of the actions could be happening in sequence, some of the actions could be happening in parallel. First, the model tries to understand, the AI system tries to understand that like what is the intent of the user. Then it tries to invoke the flight search tool. It tries to invoke the, let's say, hotel search tool. It is also having a reasoning step that like, okay, if my flight recommendations are X and if my hotel recommendations are Y, are they even matching sense also or not? Because it might not happen that like I'm trying to book a hotel when the user is already departed from Bombay. So all of these steps are happening. And then let's say once the reasoning step is also completed, let's say you have a final response which is consolidated, let's say for your use, for your consumption. So these are the different kind of evals or say different kind of traces that you're going to observe depending upon the complexity of the nature. These are just let's say for you to understand that what are the possible things that you would encounter, let's say in your day-to-day life, right? I'll take a pause here before moving to the next topic. If there are any questions, happy to answer them. Okay,
Uh,
I'll take, yeah, Vash, go ahead.
no, this is good actually. Just only question is, while we'll be doing it, we have to, what I have understood is like we have to do this traceability. It's important to, matlab, this is useful when we are evaluating our why. Whenever we are evaluating like input output, whenever somebody has given a question, what is the answer our LLMs are returning back and what are the traces of the same, right?
Correct.
Uh,
Yeah.
got it.
Yeah, thank you, Harshit. So now you understood that like what is the trace, and this trace is something like which is the most important part for you to even let's say create your LLM as judge, right? Now, once you have gotten let's say approximately 100 traces, 150 traces, 200 traces, how do you start consuming that, and how do you start kind of creating a strong evaluation suite around it, right? So it's like a 5-step process. What typically happens goes like following, right? That you read the traces, and typically the person let's say who is reading the traces is supposed to be less an SME. For example, for the product that like you're trying to build, you can understand that like as a builder, I am the SME and I understand let's say in most of the scenarios how things should play out. Now for every trace, which is let's say for every input output classification, you try to kind of benchmark it at like whether it was a good output or whether it was let's say a bad output. We will understand about it in detail let's say in the next part. Then you write something called as an open quotes. Now, what is an open quote? It's a very free form commentary about that. Okay, what are your SME thoughts about that specific thing? How do you write the open quotes, etc.? We will look at with an example. Just put a pin on this topic for right now. And once for the 200 traces or 250 traces that you have consumed, you have analyzed, and you have written open quotes around it, you try to cluster those open quotes to understand that like what are the broad category of issues, which is basically called as Excel coding. How do you do that? Like how does the output look like, etc. We will try and basically look at. And then at the same time, you also look, let's say, for something called as a saturation. I think somebody asked like a question in this session that like, okay, how do I understand that like I've read enough? You also check the concept of something called as saturation. Like what it is something that like we'll discuss in detail. So what does a saturation mean, right? Now, what is typically happening is that, let's say you are trying to basically do a lot of, you're trying to go through, let's say, multiple traces. And what is happening is that like in the entire exercises, like you are trying to have an impression in mind that like, okay, is this like a issue that I have seen in the traces before? Or is this something, let's say, which is a new issue altogether, right? So again, there's no formula here. What you do is that like you just start reading your traces, and beyond a certain point in time, you ask the question to yourself that like, okay, I have received, so far I have encountered 5 or 6 different type of issues. Whether the new issue or say whether the new failed trace that I'm looking at belongs to one of those 5 or 6 issues that I've already identified, or this is kind of a new issue that is coming all together. So this is something like which is slightly subjective. The moment you start feeling is that like, okay, if I've read, let's say next 10 to 15 or 20 more traces, and none of the traces actually contains any new issues, all of the issues are something that like I've already encountered for, that is a place where you say that like, okay, I've reached a saturation point. I probably have an understanding as an SME that like what are the different issues which this AI system has, and probably I can stop reading further more traces now, at least for this specific set of evaluation. Okay, so if you try and basically plot that in a graph itself, what you would see is that if you start, let's say, looking at the number of traces, which is a part of the x-axis, and if you look at the number of unique category issues, which is plotted on the y-axis, beyond a point in time, practically what you will start seeing is that there are no issues that you're able to encounter. And this is a place where you can say that like, okay, I have actually understood the lay of the land now, and let me start going into creating, let's say, a eval system altogether. Now we have talked about that, like, okay, you as an SME, you are supposed to read traces and you are supposed to also classify those traces at like whether they are good or bad, right? Now, whenever it comes to rating that like, okay, whether an output is good or not, I think all of us have fall for a fallacy that like, no, I want to be the most accurate person in the room. And hence, if somebody is asking my evaluation, my evaluation opinion on, let's say, a certain output, I'll be very specific. I'll try to, let's say, rate it between, let's say, 1 to 10, where 1 is the worst output and 10 is the basic is the most suitable output. And in between, whatever comes, have a degree of certainty that like, okay, probably a 9 looks like this, 8 looks like this, 7 looks like this, right? Now, I think this is something like most of us actually falls for. Whenever you're trying to put the classification, let's say around an output, do not follow the Likert scale. Always follow a binary scale, which is let's say a simple yes or no, or a pass or a failure. Why I'm basically saying so is that because maintaining the evaluation consistency as humans is very, very hard, right? So it might so happen that like for the first 10, for the first 5 outputs, you're doing an absolutely brilliant job. But as you start going further down in your traces, your evaluation criteria starts muddling up. So what is something which you have rated as 5? Now your rating is 7 here, right? So that's where you start corrupting the data a lot. So it's always possible. So you should always try and keep in mind that like as much as possible, you try to basically have a binary classification. Now for open coding, what you start doing is that like you just start describing the problems, let's say that you're encountering in the response, right? And you should be, let's say, as free form as possible. Should not have, let's say, any criteria that like, okay, these are the only 6 problems that I will basically try and identify. So you should not even you should not even try to basically put a cap on the number of problems. And you need not even basically keep in mind that like, okay, if I've described the problem as a sentence A in probably trace number 2, if the same problem reappears, how do I ensure that like I again describe it like in the form of sentence A itself, right? That is also something like which is not needed. This might be confusing you a lot that like, okay, how does it look like? So let's try and understand with the help of an example. Okay. So what we have done here is that say, imagine that let's say you have a wealth tech platform such as the likes of let's say Zerodha and Grow, and you're creating let's say a chatbot around the same. And from this chatbot, let's say you have already completed the step number 1 where an SME has read through all of the traces. What you are seeing here is like say the different user interactions that like what is the user kind of asking as a question and what is the response, let's say, which is coming from AI is what you can see, let's say in column number A. And all of them is something like which has failed the criterion of, let's say, evaluation by your SME, right? Now, when as a SME, you're trying to write that like what is failing, you can be as free flow as possible, right? For example, in this specific case, let's say the user says that like I want to sell all my shares in Reliance Industries at the current market price immediately. AI says like, okay, I understand your sale order for 100 shares of Reliance Industries has been placed. The current market price is 2,500. Now, this is, let's say, a failed thing from our SME point of view. Why? Because in any kind of a financial transaction that you're doing, and I think most of you would understand that you're investing in stocks, etc., the prices are very volatile. The user might be seeing that, like, okay, the price is 200 and I wanted to basically place a sell order. But the moment the user had decided, maybe the price dropped to, let's say, 2,400, right? So AI is again trying to, let's say, be a lot helpful and look at the way we are basically writing this commentary that, like, no confirmation or quantity or price and directly sold the shares. The second thing could be same that we have discussed, like which is an handoff issue. What is actually coming here is that like, okay, my KYC documents have been pending for verification for 10 days. I need to talk to a compliance officer right now to resolve this. AI said, I apologize for the delay. Please upload a clear photo of your PAN card again and I'll prioritize your verification request. Again, this is a classic case of, let's say, AI being very, very helpful here. What is happening here is that like the user is already frustrated. It should have handed it off, let's say, to a human being, but it is not. And what you can do is that like you can simply write in a very, very simple text form that like couldn't hand off to a human in the loop. Let's look at, let's say, one more example, and then probably we can move on. Let's say the user says that like, what is the best strategy to maximize my returns in this volatile market? Let's say whatever market is going on because of the US-Iran war, right? The AI says that like the best strategy is to book profits in your large cap funds and immediately shift that entire amount into the XYZ small cap fund. Now, this is the case of, let's say, out of scope answer. What is happening here is that like the AI is actually going leaps and bounds and saying that like, okay, I was not even supposed to provide you any kind of investment related advice, but it went ahead and it can kind of provided the same. So this is like a simple way you can take the different responses which is coming out of, let's say, any of your AI application, assess them, and then let's say write around it that like, okay, what is your observation, etc. Again, we have taken a let's say like slightly less sophisticated form where we started consuming, let's say, in form of an Excel sheet. But nowadays there are a lot of trace analysis tools also available, let's say, in the market. You can look at something called as brain dust, arise, etc. So you can also go and check it out. But this is, let's say, a very simple expression of the concept that like we have done, and we wanted to kind of teach you that like how do we do. Now open coding is done. Now the next question is that like, okay, I have written a lot of things in a free form of a text. how do I even understand that, like, how do I even categorize them now? Right? Because if I was starting, let's say, with 5 or 6 categories, the grouping of it becomes really easy for me because I've already solved that problem up in the advance. But now, since you asked me to basically write in a very, very free form of a text, how do I even understand that, like, what are the category of issues that I'm dealing with, and how many issues belongs to what category, so that I can decide that, like, what is the one thing that I should focus upon first. Now, there comes the concept of something called as an actual coding. What happens in actual coding is that, like, you try to basically classify these free form of text into broader categories. And again, like with AI, the task will become slightly easier. What you can do is that, like, you can download all of the actual codes, right? And ask an AI to kind of create. So you can all download, let's say, all of the open codes and ask an AI to kind of create actual codes around it. Okay, let's say when you're writing this prompt, just keep in mind that, like, you're using this word specifically, which is open code and actual codes, because these are, let's say, well known terminologies out in the industry. The LLM will quickly understand that, like, what is the task that you are trying to do, and the output will be of, let's say, very, very good quality. So for this analysis, let's say what we have done is that, again, let's say for the specificity of, considering time as a constraint here. So what we have done is that, like, say, we have already put it like through an LLM, and this is some kind of a pivot table that you can create that, like, okay, out of the different fail scenarios that you've had, how many of them, or say, what are the broad 4 or 5 categories or 5 or 6 categories that I'm able to understand, and what is the number of issues that you are going to face, let's say, under each category. Now, the next thing for you would be to kind of, have your PM hat on and understand that, like, if an issue is happening, how do I prioritize that, like, which issue I need to first? There are two simple frameworks. And again, I think you will be best judged as AI builders for your kind of a product that you're trying to build. You can either try to simply pick the ones, like, which has the highest number of fail occurrences, or you can also try and understand that, like, okay, even if the occurrences are less, but the cost of something failing is, let's say, very, very high, then let's say I should go and fix it first. Just imagine that, like, I'm again going to the example of where you were trying to understand that, like, okay, what is the monthly revenue for my organization? Now imagine that, like, if the number of instances of it failing is something which is very, very low, just 2 or 3, but this information is directly consumed by your strategy team, by your leadership team, to kind of decide that, like, what is the next course of business. So even though the number of overall instances of failure are actually less, but it is very important for you to pick it up and fix it right then and there, because if you do not fix it, and if a lot of decisions are taken on that specific information, there's a risk that we're looking at a lot of this information, a lot of those decisions might be going wrong. Okay, so again, for understanding that, like, what is the one thing that, like, you should try and fix first, always try to act as a subject matter expert and take a decision that, like, whether I should prioritize issue number 1 or issue number 2. Frequency could be, let's say, one rule for you to decide the criteria, but never blindly rely upon just the frequency of occurrences. Okay. If there are any questions, happy to answer, or else, let's say, we'll move to the next part. Now you have done the trace analysis, and again, like, say, we have not created a judge yet, right? Let's say, purely on the basis of SME evaluation, you have said that, like, okay, my success rate is 65%, right? Now you go ahead and kind of declare it to the larger audience that, like, hey, my AI system is working 65%. Is it the right time even for you to kind of go and declare it? Let's understand it as part of the, let's understand, let's say, more about it, right? Now, what happens, let's say, when you do a trace analysis and you have done a trace analysis, something like this, that you have looked at 5 different responses and you figure out that, like, okay, two out of those responses are correct, and hence my success rate is basically 40. Now you kind of go and start reporting it, right? So again, the idea is to be a little cautious here, do not jump the gun, because you have looked at such a small data set that, like, even the next step, where if something comes correct, the success rate drastically improves from 40 to 50%. And if it is actually wrong, then the success rate actually drops to 33%, right? So this is something that, like, you should not do. You should always try to establish the success rate with multiple runs, and also establish it with something called as a confidence interval, right? So what you should do is that, like, you should say that, like, okay, I'm trying to run multiple batches of my outputs, and I'm trying to understand that in how many cases I'm getting success, I'm getting failure. And with a 95% confidence rate, right, my success criteria lies in this specific range, right? Now, if it is happening that your success criteria is, let's say, coming out to be, let's say, in a very, very wide confidence interval. Maybe you have not run it multiple number of times. So try and basically do more sort of analysis, etc., to establish the success rate, let's say, for your AI system. But let's say if a confidence interval starts becoming more and more narrow, this is where you start becoming, let's say, more and more confident that, like, no matter if I try and basically run this again, or let's say even if I try it, let's say, 2 more times, 10 more times, my success rate is not going to change a lot. So always keep in mind that, like, do not jump the gun when you're trying to report the accuracy or the success of an AI system. Start measuring it, let's say, with a confidence interval. The second fallacy which starts coming into the question, or say which into the system, is that you start basically measuring the performance, and when you're measuring the performance, maybe you're measuring the performance only for a specific segment of the user choice, only for the specific segments of problems, right? So let's not even read this specific, let's say, slide, right? Imagine that you are trying to evaluate the hospital, let's say, for some kind of a surgery which is happening, let's say, in your friends or family, right? Now that hospital reports that, okay, our surgery success rate is 90%, but they have not given you any other information. Now, will you even go and trust that hospital? Maybe no, right? Because it might so happen that, like, the hospital specializes in doing, let's say, a lot of routine surgeries, and there their success rate is very, very high. But whenever they have attempted an open heart surgery, their success rate comes down to be, let's say, approximately 60%. Right? So unless you have tested, let's say, your system across the use cases of different nature, etc., there should be no need to kind of report the success rate or accuracy. Should try and measure the accuracy of the system across different use cases. And, like, in case of a shopping bot, what are the different segment of use cases that you can think? Let's understand. The first thing could be, let's say, exact query. Okay. The user is, let's say, is exactly the user knows that, like, what he's looking for. Let's say I'm looking for a iPhone 15 Pro, which is 256 GB and black in color, right? Now, this is, let's say, a very simple query, because what could go wrong here is that, like, say, maybe in place of a 256 GB phone, I'm getting, let's say, a 124 GB phone or 128 GB phone. Or let's say maybe in case of a black color, I'm actually getting a blue color as the response. So this is, let's say, one place where things could actually go wrong. The second could be, let's say, slightly more exploratory queries that, like, user has a goal but does not have a fixed product in mind. So there's some amount of ambiguity here. And there are, let's say, multiple valid answers which are possible, let's say, for the specific question of query of users, right? Let's say the user asks that, like, get me the best phone which is under 30,000 rupees. Right? Now, what could go wrong here is that uh, there could be certain things, like, which could be coming, which could be irrelevant products. In case of phone, you might actually start getting a lot of, other electronic devices. Or there are times that you actually start missing, that your AI system starts missing the budget constraints also at times, right? So if you completely tested your AI system only on the exact query match, which was a slightly simpler use case, and started reporting success around the same, that's not the right precedence, because you should start looking at the different spectrum of queries, right? You should also test it, let's say, for certain long tail queries, like, which are not seen enough in your system but are complex enough, right? For you to kind of even understand whether your AI system is even working correctly also or not, right? So let's say something is coming with a very, very nuanced need of the user. User says that, like, okay, I want a office chair for lower back pain, which should be ergonomic and should be, let's say, under a budget of 10,000 rupees, right? Now, in this case, what might so happen is that, like, you start throwing a lot of irrelevant products, and you could also start throwing a lot of generic items. Let's say you can start throwing a plastic chair, which is probably under 10,000, which is just around 1,000 rupees, because it is performing best on your platform, right? Now, in all of these cases, let's say, unless you test your AI system across these range of different user queries, different segments of complexity of problems, you should not go and report the success rate of your AI system just like that. I'll take a pause here. If there are any questions, happy to answer. Otherwise, we'll start understanding more about this RAG architecture in detail for evaluations.
No, this is good. Can we take a 5 minutes break if possible?
Sure. We can take that. That's okay.
Yeah, thank you.
So I think it's 11:19 right now. Let's huddle up back at 11:25. Hey guys, are we back in the room? If you're back, just give a thumbs up in the chat box so that we can start, or we can wait for a minute or so that the rest of the people can also join in.
Yeah, meanwhile, we can present the screens.
Hey, just give me a minute. Okay, I think it's almost 11:26, so we'll start now. We'll start now understanding that like, okay, how do I look at the evals for any specific kind of an architecture, which is, let's say, slightly complex than like what we have understood so far. So we'll talk about something called as a RAG. Now, why, let's say, evals for RAGs are, let's say, very, very different. Let's try to understand this. Just, just give me a minute. Yeah. Okay. Now, RAG module, right? The full form of RAG is something called as retrieval augmented generation. It's a two-step process, which basically contains of retrieval and generation. Now, what typically happens is that, say, LLMs are trained on the world's knowledge, right? But they are not trained upon the knowledge which is very internal, let's say, to your ecosystem. Imagine, let's say, in whatever companies that like you're working, there could be a lot of documents which are not available, let's say, out in the web, and are only available to the internal audience. Now, if you want to kind of use this intelligence of the organization to create something, let's say a very important or say a very common use case that comes to mind is the written policy use case that like I've just thought about. In all of such cases, like we use like we use something called as a rack system, where we first try to ground our AI system into the available knowledge of the ecosystem of the organization, and then ask it to generate the output from that knowledge itself altogether. Right? So whenever, let's say, we are creating such kind of a system, just looking at the output answer that like what is the model even giving as an output does not suffice it. So if you just start looking at the output that like, okay, whether the responses which are coming from the model are true or not, this is not the right way of looking at it, because it might so happen that like, okay, if things are going well, if things are passing, then it is not a concern. But when things starts failing, that's it, things start failing, you have to also, let's say, keep in mind that like, okay, at what specific part things are failing, whether it is failing at retrieval or whether it is actually failing at generation. Because let's say if your AI system was not even able to find the right source of document for answering a user query, then in no case the generation is going to be accurate. So a wrong retrieval will always lead to a wrong generation. Okay. Now let's understand RAG. Let's say maybe if you're hearing for it for the very first time, let's understand it a very, very simple example. Okay. Uh, let's say you go to, let's say, any famous Italian restaurant. Let's say if you're around in Bangalore, let's say you're going to something called as a Pizza Four Piece, or let's say or something called as a Via Milano, right? And you're trying to basically order. You have in mind that like you want to eat, let's say, penne pasta, right? Now, when you are going to place an order, right, there are a lot of steps which are even happening, let's say, before that, right? So something which could be happening is that, okay, for you to even get the penny pasta, somebody in the procurement team has to go and shop for all of the ingredients. Then comes the chef in picture. Let's say he has to take all of those ingredients and, let's say, mix them in the right proportion and create a dish for, let's say, for you. But let's say what happens if in place of, let's say, penne pasta, the shopper actually bought fusilli, right? So, and there's no penne, let's say, which is available in the stock, right? So if the shopper was not even able to get the right ingredients for you, there is no way the cook can actually create the right dish which you are actually asking for, let's say, in the restaurant. Okay. So when we are trying to do an evaluation, in this case, the evaluation needs to happen for both retrieval and generation. Now, in this specific example of RAG, so far we have focused upon a very generic case of an evaluation where we are just looking at an output which was happening through a generation process, and then trying to understand that like how do I kind of create an evaluation suite for the same. In this specific case, we are going to focus a lot upon the retrieval part, because generation part is something that you're already aware about in some shape and form by now. Okay. Now let's start understanding this RAG evaluation, let's say, in more and more details. Now, one thing that might come across as a concept is that, say, many people, when they're trying to understand this retrieval as a concept, retrieval quality as a concept, there is a school of thought that, like, okay, I'll just look at the similarity between the query, the user query that I'm getting, and I'll also try to basically simply look at the similarity of the document which is coming in the very, very first place. Okay. So typically what people do is that they will try to create the user query into some kind of an embedding format, and they would also try to convert, let's say, the available documents into some kind of an embedding format. And when it comes to, let's say, retrieval, what they will look at it is that, like, okay, what is the similarity score coming out to be? In case, let's say, my similarity score is coming out to be very, very high, I'll say that, like, I've done, let's say, a great job at retrieval. Now, this is something like which might work in certain cases, but might not work in certain cases. And there are, let's say, a lot of pitfalls that you might actually encounter. So what similarity is doing is that, like, it is just trying to measure the geometrical closeness, right? So what happens is that when you try to basically convert, let's say, any kind of an artifact or any kind of a text into embedding, there's a vector space that you're creating, and inside that you're trying to plot these two things. So let's say this is the user query, and this is, let's say, the embedding, let's say, of the similarity document that you have, right? In case they are very close apart, right, you'll say that, like, okay, the similarity score is very, very high. But if they're, let's say, very far apart, let's say, in the vector space, your similarity score will actually come out to be, let's say, very, very weak, right? Now, one framework to basically say is that, like, okay, if my document is very close to my user query for embedding, I have done, let's say, a great job at retrieval. But there are certain cases where things start failing. Let's take this simple, very example, right? So again, you're trying to basically build a chatbot, let's say, for your CEO, who just wants to understand that, like, okay, as a platform, I run multiple storefronts. There's a dedicated mobile application. There's a desktop website also available. And I want to understand that, like, say, people who are coming and shopping through my mobile app, like, say, what is the conversion rate for those users? Right? And the document or the query that, like, it actually figured out was something which talked about the desktop conversion. Now the similarity could be very, very high because both of the things, which is the user query and the retrieved documents, contains the word conversion, and hence, like, in the embedding space, they're coming closely together. But the relevance is still very low because the CEO wants to understand about the mobile conversion, but you're teaching them about something called the desktop conversion, right? So these are the cases where you should be wary about directly using similarity as a metrics for checking the retrieval quality. And if you want to kind of check the retrieval quality, you should start measuring metrics such as precision at K, recall at K, and MRR, which is nothing but mean reciprocal ratio. Now, what does each of these things means? Let's understand in detail with the help of an example. Okay. Now, the usage of this metric. So it is not required for you to use all of the metrics, let's say, in all of the use cases. This is where the job of you as a builder becomes very important. You should try to understand that, like, what is the context in which you are trying to build your AI system. And as per the context, you should try and decide that, like, what is the metric that I want to use. For example, let's say you're creating an AI system where the context window is very, very small. Now, what is the context window? It is nothing but, like, what is the amount of data which a model can restore and kind of retain while answering a question again and again. Because every AI system has some kind of a limit. But the moment the information that you have provided starts going beyond this context window, it starts kind of neglecting something that, like, which was fed to you by the AI system earlier, and it starts just focusing upon the recent information, right? Now, what are some of the example of low context windows? Let's say very early stage LLMs models that we had, like, which is ChatGPT 2, ChatGPT 2.5, all of them, like, had very, very low context windows. And something which is coming very recently, let's say the likes of an Opus 4.7, it has a context window of up to 1 million tokens, which is, let's say, very, very big. Okay. So if you are kind of trying to deal with a use case where the context window is very, very small, the metrics, which is precision at K, becomes very handy. Now, what is precision at K? Precision at K is nothing but like a ratio of true positives divided by true positives plus false positives, right? Now, let's not even read about this formula. Let's try to understand it a very, very simple example, which I have placed, let's say, on the left side of the slide. Okay. Now, let's say you're working, all of us, let's say, are working in a banking industry, right? Now, what is the biggest problem of banking industry? How do I prevent frauds? Now, even in banking industry, when it comes to preventing frauds, the number of occurrences of frauds are, let's say, not very, very high. So let's say if I look at all of the banking transactions, in a realistic scenario, 99.5% of the audience who are dealing with the transactions are actually good. And only there are approximately 0.5 or 0.3% of the audience who are trying to game the system and do certain fraudulent transactions. Now, the different transactions that are happening across the platform, let's say these dots represent those transactions. The ones which are coming, let's say orange in color, are actually fraudulent transactions. And the ones which are green in color are perfectly good transactions. There's nothing which is wrong about the same. Now you're basically creating a system where you're trying to undertake each and every transaction into account and then trying to basically label it that like, okay, whether it was a fraudulent transaction or not a fraudulent transaction. So the meaning of true positives or false positives starts coming when you try to understand the effectiveness of these labels, versus their true nature. So what possibly you could have is that there could be something which is a genuine transaction and you have also labeled as a genuine transaction, something let's say which is not a genuine transaction and you have labeled it as a genuine transaction. So all of these multiple combinations are possible. Now, what are the true positives cases? True positives cases are the ones, let's say, where you predicted them as fraudulent transactions and they were actual fraudulent transactions also. And what is a false positive case is that, like say in reality, it was a fraudulent case, but you have predicted it to be non-fraudulent, right? So this is like how precision is calculated. In this case, precision is nothing but let's say 2 by 3, because you have two true positives and let's say you have two positives and let's say one's false positive as well. Right. Now, in this specific case, let's say what's going to happen, let's say if your moderate context window is very, very small, if you are able to retrieve a document which is not even relevant, let's say you only have a context window of very small and the user asks that like, okay, get me something which talks about the returns policy of my platform. And in place of returns policy, it talked about something called as the seller onboarding policy, let's say for example, right? Now, if the context window is very, very small and you have fed one of the document which is non-relevant, the model is not, the AI system is not going to work, let's say, really, really well for you. Okay. And this is something like which is all, let's say you're trying to create a AI system which is on device. So you're not even calling, let's say, an LLM, or say you are just like having an SLM which is installed on the user's device. Now, for all of such cases where a context window is small, you should be very, very of the fact that when you're trying to get the retrieval accuracy, your focus should be on maintaining the precision at K value should be very, very high. Okay. Any questions so far? Okay, I'll move to the next concept, right? So the concept of recall at K. Now this concept starts becoming very important when you're taking certain high stakes decision, right? So the situation goes like following that, like if you miss even a single, let's say, relevant document, right? It could change the outcome drastically. Okay. So let's say you are trying to predict something which is a cancerous case. So let's say you're trying to predict like whether a person could actually have a cancer also or not, right? Now imagine that like if you ended up predicting that a patient like who actually has cancer does not even have a cancer, what are the ramifications, right? He will probably not get the medicines and his condition will actually deteriorate, and then eventually he'll actually start facing consequences which are going to be very, very fatal, right? So how do we basically explain recall? Recall is nothing but the cases where something was actually cancerous and you were able to predict it, and something which was cancerous but you actually predicted as non-cancerous, right? So I think in this example, right, there was one thing that I think we skipped, right? So what was precision at K? That something which is actually fraudulent and you predicted it to be fraudulent, right? And something which was not fraudulent and you predicted it to be fraudulent, right? So I think I kind of jumped the gun here and kind of said that like our precision is 2 by 3. It is not 2 by 3, it is actually basically 2 by 4. Because if you ended up, let's say, catching transactions of somebody who was a let's say I'm a customer of the bank, right? I'm not doing any kind of fraudulent activity. But if you mark myself as fraudulent also, right? Then imagine the ramifications for me, right? Like the kind of ordeal that like I have to go through, right? So this is something like which is the concept of precision. In case of recall, you would, so the idea in precision is that like, okay, if something is non-fraudulent, you should not try to basically make it fraudulent. Okay. While the concept in recall goes like following that, like, okay, if something is basically, if a patient is basically cancer, I want to figure out that particular patient, no matter what, that like in the entire process, even if I start predicting some of the non-cancerous patients as cancerous patients. Okay. So here, let's say my recall is something like which is 2 by 3, because out of 3 cancerous patients, I'm only able to detect 2, and 1 cancerous patient I'll basically predict it as non-cancerous patients. Now, these kind of metric, which is recall at K, for your retrieval systems becomes very, very important when your decision that you're taking is very, very high stake decision. again, going to the same example, you're creating, let's say, a medical rack. Where you're trying to basically create a system which is as intelligent that doctors can use it and they can assess all of the important medical records of a user to reach at a conclusion that like whether this user is actually having any kind of a risk of a specific medical situation or not. Imagine that like an important blood report is now missed by our retrieval augmentation system, the retrieval system, right? The kind of ramification that it has, let's say for the user is something, let's say, which is very, very high. And hence, whenever you're trying to create any rack system like that, focus a lot upon recall at key metric. Even let's say if your precision at key kind of goes for a toss, you should try to maximize the recall at key metrics. Okay. The next example that comes to mind is something called as a legal chatbot. In the same case, let's say if there's any important legal document which gets missed by the users while retrieving, it has a lot of ramifications for the end users. And hence, in all of such cases, you should try and focus a lot upon the recall at key metrics, even let's say if your precision at key metrics starts going for a toss. Now there's something called as a third kind of a system where it does not just matter that like, okay, you're retrieving the right document. The sequence or say the position at which the right document is placed also starts making a lot of sense. Okay, so there we basically use something called as mean reciprocal ratio. What it does is that like it just not only takes into consideration that like whether the document was right or wrong, it also keeps in mind that like, okay, what was the rank of my document? So if the first document was something like say which was founded at the very first place, the value becomes 1. So this is nothing, let's say you try and basically run this use case, let's say multiple number of times and try and see that like what is the mean which is coming out to for you, right? So in the very first instance, let's say if the rank of the relevant document was 1, this score becomes 1. Next time you run it, the rank of the first document was 2, it becomes basically 0.5. The rank of the relevant document was third, it becomes 0.33. And let's say in the fourth run that you are trying to basically do, the rank of the relevant documents becomes 10th. So the ranking score becomes, let's say 1 by ranking scores becomes just 0.1. You sum all this 4 scores and divide by 4 to basically get your MRR, right? Now, in cases, let's say, again, going to the shopping bot example, let's say user types a query that I want to basically get an iPhone, which is 256 GB black in color. Now, as long as your MRR is high, right, it is a good system that you have built, or the retrieval is actually happening in a very, very good quality, in a very, very good manner. Because if it starts, let's say, coming down the order, then then your user will just look at, let's say, first 2 or 3 results and say, that, okay, boss, the results are not even relevant, and you'll start seeing, let's say, drop off in the user funnel, right? So for all of such cases, something let's say such as an FAQ sheet also, right? So let's say if you are landing the user of an FAQ sheet, then you should also keep in mind that like say the ordering in which you are having the answers to the user query, the most relevant response to the user query should come and start sitting on the top, because the moment you start sliding it below and below the order, the user will actually start losing trust and they will not pay a lot of attention to whatever thing that you want to showcase them, right? So MRR as a concept becomes really important when it is not just about retrieving the right document, but it is also about it like how you're sequencing in the set of documents that you have retrieved, right? So a quick summarization of the slide. Say in the different kind of, let's say, RAG architectures, for a different kind of use cases, the metric that we need to focus upon also kind of changes. For example, if somebody is trying to basically do a search for a medical records, you should try and basically focus a lot upon the high recall at key kind of a metric, because the reason for the same is that like if you miss out on an important report, the entire outcome could turn out to be, let's say, very, very fatal for the user. If the nature of the product is to kind of get certain search results and surface it back to the users, your focus should be to kind of create a system where the MRR is coming out to be really, really high, because the entire success of your product depends upon that, like how much up you are able to kind of surface the right answer to the user's query. And to the third case where your context windows are very small, let's say it is very small as such as, let's say an on-edge device, or like you're trying to use a legacy model which does not have a very, very high context window. You should try and basically focus on the fact that like how should I increase the precision of the system, because you would not want to feed any kind of a garbage document to the LLM. If you feed it, if the context window is very small, no matter how good, let's say, is your prompt, etc., which is working behind the scenes, you will not get the right answer because the context window itself is very small. So this is, let's say, how and what are the set of metrics that you should try and focus while trying to create, let's say, an evaluation suite for a RAG system, especially focusing upon the retrieval part. If there are any questions, happy to answer, else we can move to the next section. for this specific discussion today. Okay, I'll take it as a note. Now we'll start focusing upon something called as an LMS test. Okay, we have understood that like what is an eval. How do I even kind of understand that like where eval is even needed? How do I even understand that like what are the issues which are facing, which my AI
Hey,
system is
am
facing?
I so sorry? Am I audible? My
Yeah,
audio.
Jashan, you're audible.
Yeah. Hi. Just wanted
Hi.
to check that you said depending on the requirement, we may use different precision models, right?
Yeah.
So, can the scenario be where for one use case we are using one model, and for other one we may use another model, but the entire architecture remains one single use case? Is it technically feasible to do so? Uh,
It might actually, right? So again, let's talk about like a specific use case again. And again, like say when we were talking about the previous slide, we were just talking, let's say, the kind of retrieval metrics that you should focus upon, right? So
right.
imagine that, let's say, again,
I'll
like say
I'll
going,
I'll give you example because I'm working on a similar use case.
sure.
Let's say in banking industry, if I want to have a train my algorithm for deriving the available balance. Now the customer may have multiple accounts, and I'll fetch it and then rank it accordingly and give a total available balance along with the breakup of different accounts.
Hmm.
Okay, this can be one use case. In the same model, I might need to evaluate the customer propensity for availing a loan.
Hmm.
Okay.
Hmm.
And in this scenario, the precision model, I believe, needs to be different, because right now we are not just fetching in the or retrieving the customer document. We are also ranking and giving the weightage to the documents accordingly. So my algorithm, my model for these two different scenario for the same customer on the same bot may be different, right? And is this architecturally possible, and how financially feasible is it?
So just want to take a step back, right? So if I look at your first question, just help me understand if I understood your question correctly. The
Mm,
scenario that you are painting, and again, I do not have experience in banking, so just trying to understand, like, with your help here. The scenario
mhm,
that you are painting is that, like, you have a user, or let's say you have a user account, and
mhm.
that user has multiple different accounts with you, and every account has some kind of a different balance, and you are trying to aggregate the same. Is it the
Correct,
first part that you're trying to distill? Okay.
correct,
So
correct,
just
correct.
wanted to understand here, like, say, then this is, let's say, a very deterministic kind of a problem, right? So how exactly are you using AI system here? Because let's say, like, again, probably just pardon me, let's say, for my naive understanding here. Let's say if the
Mhm,
user is associated, let's say, with a single user ID, let's say that user ID is 123. And for
mhm,
that user ID, there are, let's say, multiple accounts which are linked to it, which is 456, 768,
mhm,
so on and so forth,
mhm,
right? It's a very simple thing that, like, okay, you look for, let's say, the specific user ID, find
mhm,
all of the child accounts which are associated with it, and
mhm.
look at the balances and just aggregate and show it to the user, right?
Uh, there are nuances to it, because a user may, let's say, have an OD account where balance is always negative. And
Okay.
if you sum it up with the remaining savings account scenario
Hmm.
and just total it up, you may end up having completely wrong available balance. I've done this
Okay.
mistake in one of my previous
Okay.
scenario.
But
So
just okay, go ahead.
yeah. So
Yeah.
not just the bot is expected to fetch the details, but interpret it accordingly.
Which is true, Jashan. But what I'm just trying to say here is that, like is it like even a system where you think that is any role which any kind of an AI system has to play? Because let's say in my mind, right? Again, like I'm not very well aware about, let's say, how the system etc. works. You can simply, let's say, create a classification criteria also that, like, okay, I have a user ID, I have, let's say, multiple accounts, and then, like, say, every account balance is also of a specific time, let's say an OD balance versus let's say normal saving balance. And when I'm trying to aggregate it, let's only just focus upon let's say the saving banks account, right? So it's a very deterministic kind of system, at least like say from what I'm able to understand it, not able to clearly understand and appreciate the fact that like say what is the role of let's say any kind of an AI tool which is getting played here, or any kind of an ML tool which is getting played here.
Oh, I mean, I can definitely elaborate more
So,
on that.
so just like to add to the Abur's point, what he's saying is, like also I like in line with the opinion of Apur, I don't think there is a need of a rag here, right? Because let's say you have a person can be like, what is the number of amount you have for a particular user, right? It can be 10, 12, right? If you think about the combination, it will be a very let's say limited number of combinations as well, right? If you are taking, let's say, n account out of 12, so 12 ck is the number of combination. I don't think it's a fairly probabilistic problem to use rag here, right? Because you exactly know, like it will not happen that for every user you have a very very different combination of account you are getting. So I'm also not able to appreciate like why we are even using or thinking about using rag to retrieve the accounts here. Is it possible that let's say there are 10 million users and all 10 million users can have 10 million or more than 10 million combination? That I'm not able to appreciate.
Okay.
Because
Or just maybe let's say if you have to evaluate also, let's say, right? Then I think if you would have followed right in the earlier part, let's say we have discussed something about code-based evals, right? So maybe let's say if you are trying to let's say validate the responses of any kind of an aggregation that you're doing, code-based evals, let's say is the right thing, which is a very simplistic form of let's say evaluation, is what I think Shailesh is also hinting at.
Hmm.
yeah, because here I'm not able to see, let's say, any need of AI systems. So that is also very important thing to understand, let's say, when to use AI, when not to use AI. If it's a limited set of input and output, like then you'll definitely go with the deterministic thing. Like why to invest so much of cost and everything for, because your output is deterministic and very limited number of output. It's not that it's a customer sentiment analysis sort of testing, like very, very naive example where there can be input, any input, and the output needs to be defined based on, let's say, any combination of billions of input, right? So that is the thing I want you to think about, whether you actually need rag here or not.
Okay.
Yeah. And
So,
on your second point, where let's say you have gotten, let's say, the input of the account from, let's say, for a particular user. Now, let's say you think about whether to give loan to that person or not. That I think can be still be done by AI. Because you have let's say, lot of dimensions. Dimension as in, let's say, your age, your account balance, what industry you are working in, let's say, what is the salary. So these are, let's say, different dimensions of a user, right? They treat it as a, let's say, user vector where for a particular user you have all these dimensions. Now from given that user, whether you should give them, let's say, avail the loan or not, that can be a let's say your definitely a AI problem. But still, whether you should LLM for it or not, that is also that you definitely should not use LLM here, because there is n number of off-the-shelf model available. Let's say you can go to Hugging Face, lot of available tools, and let's say AI models are available. You can directly plug and play and use that. If you're utilizing this information, giving back to LLM and getting, so according to me, it's just like a force fitting sort of use case. That is what I can assess now.
Yeah, and just like I mean, just to extend this point, let's say even if you're using an off-the-shelf model and you want to assess that like how good your model is performing, maybe I think you're coming from the fact that like whether I should measure precision at K or recall at K, right? Because in one case, and I think a lot of it also depends upon your organization strategy. For example, if you want to maximize your chances of let's say getting a loan, and in that specific thing, you're okay, let's say, to ding certain customers also, let's say, who are not even needing loan and just irritate them. Maybe precision at K could be the right metrics that like, okay, I'm just trying to, or say maybe you're not, let's say, trying to optimize for a recall, right? You're just trying to kind of reach out to as many as consumers, right? But if you want to, let's say, focus specifically on the customers, like who are in a need of a loan, right? And let's say do not want to disturb the rest of the customers, then you can choose your metric accordingly. So a lot of it that like, how should I measure the efficacy of system also gets hinged to that, like what is the outcome that you're trying to basically derive.
Okay, got it.
Yeah.
It's good. Yeah.
Okay, so let's move to something called as, let's say, LLM as judge, right? Now, what this basically means is that, say, when you are creating, let's say, any kind of a judge, you should just basically have three things in mind. Uh, First thing is that, like, you should have a rubric in place. Now, what does this rubric do? This rubric is nothing but like a detailed criterion of, let's say, what makes like a good example, and what basically makes a bad response for a given output, right? And this is something that you can not only just describe, let's say, in your input prompt, but you can also, let's say, attach a few short examples around the same. Then the second thing, I think, which is which the name itself kind of connotes, is that whenever, let's say, it is basically for an LLMS judge, you definitely need, let's say, an LLMS place. And for that, you can use, let's say, any out-of-the-shelf LLM model, which basically helps you evaluate the response, right? Ideally, I think there are, let's say, multiple thoughts here. So typically industry advises that, like, you should try and use like an advanced model is just because it has a better understanding of the context. And since like the output is going to get consumed by the users, you want to be very strict in terms of what you want to show, what you want not want to show. But then the question comes in mind that, like, if my AI system already uses, let's say, a very advanced kind of a model, where can I go and actually find a more advanced model, right? So using, let's say, same tier of models having the same amount of intelligence is also okay, because anyways the prompt that you're going to input, the model which is used in an AI system is, let's say, prompt A, and the model which is used as LLM as judge, it is basically prompt B, right? So that's okay, let's say, even if you use a model which is of the same intelligence level, right? And the third thing that, like, you would actually want in any kind of an LLMS judge is that, say, okay, what is the final judgment which is coming out of that LLMS judge, and a reasoning around also the same, because let's say if you were to later understand that if your LLM is even providing the right answer also or not, you have a reasoning layer to even go and understand that, like, okay, if LLM went wrong about it, what are the reasons that why it actually went wrong about it, and you will also start getting a lot of cues at, like, how do I actually go and fix the same. So let me just showcase you, let's say, a sample prompt that we have for, an LLMS judge. And again, let's say we will not spend, let's say, a lot of time here. Uh, so again, let's say in the same example, when you have, let's say, multiple different type of issue, and it might so happen that, like, you have to write multiple different kind of an events, because if the problem state is, let's say, so wide, it is also not advised to create like a single LLM judge which can create, let's say, a lot of these things together, because then, let's say, if the judge itself starts becoming so long, it might actually be very confusing. So let's say that for the customer handoff deficiency, you can first, let's say, define the role, that, like, what is the role of the specific LLMS judge. You can, let's say, also define, let's say, some of the rubrics for the same, that, like, okay, what is something, let's say, where an handoff issue happens, and a kind of how to handle the same, etc. And then you can also add, let's say, certain few examples where from your data itself you have understood that, like, okay, these are the issues which are happening and how should the model act, right? So this is, like, say, typically how do you create, let's say, the prompt of LLMS judge. And once you do the same, right, this part is something, like, say, which becomes very, very important, right? That how do you effectively use your traces to kind of even come up, let's say, with a specific prompt, and how do you fine tune it, right? So in the very first phase of this entire discussion, what we have learned about is that, like, we already have something called as a trace analysis. And what we have done is that, like, there we have also done the output classification, that, like, whether this output is looking correct also or not. And for every output classification, we have also written the open codes and actual coding for the same, right? So the precursor of this step is that you have already gone through multiple amount of traces, multiple amount of instances. And for every instance, let's say you already have labeled an SME data, or say you have labeled them with an SME output, that, like, whether it was a good output or whether it was, let's say, a bad output. Right? Now, in the prompt that we have shown you, like, there were certain few short examples that, like, you have to introduce there, right? So out of the different cases that you have observed here, let's say you have 100 trace data which is available to you. Just use approximately 10% of it, which is approximately 10 examples, to train your model that, like, hey, this is like how it should behave, right? Then as next step, you should basically take the remaining next 50 traces or 45 traces, and then try and see that, like, how your prompt is performing. Okay. If your prompt is not performing good, let's say on the next 45, 50 batches, maybe this is the amount of trace that you should try and basically use to fine tune the prompt further. Maybe it might so happen that, like, you have not handled, let's say, one of the use case here. And hence, when you try to run it, let's say, in the next 45, 50% of your traces, you figure out that, like, this use case is not handled, and you try and basically fix the prompt, and then again try and see that, like, whether the performance is coming out to be good of LLMS judge also or not, right? Then the next 50 set of examples that you have, right? This is something that you should keep untouched. So this is the final golden data set for you, because you already have an SME label available here that like whether it was a good response for the AI system also or not. And then eventually, right? You have also fine-tuned your LLM prompt enough that like now it should start attacking this 50 or let's say 45 odd traces in the completely good manner. So whatever response which is coming out on those 55, 50 is something that you should start noticing correctly. And never it should happen that like, okay, you figure out a deficiency here and then you're trying to basically use this one of these examples to kind of fine tune a prompt. Because if that happens, then what essentially you're doing is that like you're kind of overfitting to the test set. You have made your test set enough itself so big as the production data set that like the model has seen all of the scenarios and it will start kind of giving you the right output for every scenario that it is actually seeing, because you're just overfitted the test. So never do something like this. Whatever fine tuning that you have to do, just use this specific 45 50 set. Do not touch the remaining 45 to 50 of the traces that like you have. Always use them to see that like how effective your judge is actually performing. I'll take a pause before moving to the next part. The next part, which is also very important, is that like, okay, we have started this entire session saying LLMs are non-deterministic, but at the end of the day, you're asking also us to use something called as LLM as just, which itself is basically non-deterministic. So is there a possibility that whatever variation which is going to come out, let's say in the output of LLM as just, a lot of it also has to do with the non-deterministic nature of LLMs? Yes, it is possible, right? There is no shame in saying that like, okay, LLM as just is something like which is perfect, right? But as a builder, you have certain ways to kind of reduce this variation which is coming off out of the non-determinism nature of this LLMs, right? Now, how can you basically do the same? So whenever you're using an LLM as judge, you should basically fine tune it to reduce the model's creativity using the temperature setting. So what is a temperature setting? A temperature setting is nothing but it is a parameter that controls the randomness and creativity of an LLM's output, right? So if a temperature is basically very, very high for a set for a model, it tries to be, let's say, more random because it is trying to be, let's say, more and more creative. But a low temperature model is something like which tends to be, let's say, more focused and provide, let's say, deterministic output. But the next question which will come to your mind is that like, okay, if the temperature value ranges between 0 and 1, and if I set the value of temperature as 0, will it solve all of my problems? Maybe it will solve a lot of your problems, but not no, because what might happen is that, like say, even if you have a zero temperature model, it will actually lead to it will lead to basically non-zero variances, because the hardware on which you are trying to basically run could be different, different batch sizes in which you are basically trying to run your LLMS just. So it even after, let's say, setting the temperature 0, you might receive 90 to 97% of the times consistent outputs. But there are time of cases, let's say when you try to rerun the same output again and give it to LLMS just, for 3 to 8% cases, you might actually use different outputs. So always take the output which is coming out of an LLMS just with a pinch of a salt. And since the problems that you're going to handle as builders are so huge that nobody will try and say that like, okay, make this LLMS judges perfect, right? Because everybody knows this fact that like, even if you set the temperature setting to 0, there's going to be some amount of variation. Now let's come to a very important topic, right? So, okay, we have understood what are AI systems, how their evaluation is very different, why it is not possible for a human to judge it, right? And hence we have understood that like what are the type of evals, which is code-based eval, off-the-shelf ML model evals, and also let's say LLMS judge evals. We've also understood the process of creating, let's say, LLMS judge, and we have also understood that like what is the accuracy of system and etc. But at the end of the day, how do I even understand that like whether my LLMS judge is giving even the right output or not, right? So how do you even understand the same? The only way you can understand whether the output of LLM is correct or not is to basically benchmark it against that, like if a human or let's say I as an SME has to kind of treat this or evaluate this outputs, what will be the agreement, let's say, coming out between these two systems? If my agreement is high, let's say if the human is also saying, if the agreement between a human and an LLMS judge, let's say is 90% of times, maybe I've created, let's say, a good LLMS judge. But when it is, let's say, lower than, let's say, 30-40%, maybe my judge is not doing a good job, right? So as a builder, your responsibility will also be to measure that like how many times your LLMS judge is agreeing with the SME, right? Now you can simply create an Excel sheet saying that like, okay, I'll look at the columns, I'll take 100 instances. And I'll take the instances where both humans said, when humans said yes, LLMS judge also said yes. This is like a good case for me. When humans said no, LLMS judge has also said no. This is also, let's say, a good case for me. And I'll simply basically come across and say that my agreement, right, or say my LLMS judge matches 70% of time with the human responses. Right. Now, the question comes to your mind is that, like, is it even a good LLM judge? And somebody might ask in the room that, like, what if this agreement is happening by a mere chance, or it is happening, or is it like say a true agreement? Because if I just ask LLM also to kind of rate things randomly, there's also a very good probability that, like, some of the times it starts matching the you know judgment, let's say, of a user. Right? So this 70% number is something that you should not just go and directly report to your stakeholders or to your, let's say, C-suite or the steering committee. You should also try to understand that, like, how much of it is coming because of, let's say, a true agreement, and how much of it is because of randomness. And how do you do the same? You use the concept of something called as Cohen's kappa here. Right? Now, what is Cohen's kappa? Uh, Again, like, it is a simple term, let's say, which is used, let's say, in the ML industry. The idea here is to basically understand that, like, if there are two raters, so let's say I am a rater and Ayush is, let's say, another rater, right? And if you're trying to, let's say, evaluate the output of the same set of problems, how much times do we agree just because there's a possibility of us agreeing because of random reasons, right? Because let's say I was just simply saying yes, 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 no, 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 and Aisha was also doing the same job. So there's a good probability that without even putting our evaluation hat on, just because of random choices, our agreement is kind of reached. So Cohen's kappa gives you one lens that how to take out this possibility, or how do I even understand that, like, what part of my agreement is coming because of randomness, and what part of it is something like which is not coming because of randomness. Now, how do you basically calculate it? Right. So you calculate it, let's say, in form of a ratio. The value is something which lies between -1 to 1. Okay. So what actually happens is that this is, let's say, a ratio where we say, like, it's a P0 minus PE divided by 1 minus PE. What is P0? P0 is observed agreement, the 70% value that, like, we talked about, let's say, in the previous slide, right? What is PE? PE is nothing but an expected probability that, like, we have to calculate. Again, you need not, let's say, put up a, let's say, pen and pencil. There are multiple uh, Python scripts available to kind of do the same. What is expected probability? It is nothing but the summation of multiplication of probability when I said yes and Ayush said yes, plus multiplication of probability when Ayush said no and I said no. Okay. Now you try and basically just calculate this ratio. And this is like a table which you can use to understand that, like, if a kappa score is actually coming and you have a value which is coming out of this specific ratio, how do you interpret it? Right? If it is less than zero, maybe, let's say, this agreement was not even there. It was very, very poor. If it is between 0.01 to 0.0, at least I and Ayush agree to a certain kind of a um, to a decent kind of length, right? If it is coming between 0.1 to 0.4, the agreement between me and Ayush is actually fair. If it is 0.1 to 0.5, it is a moderate agreement that, like, we have into our evaluation, let's say, judgments. If it is 0.1, 0.61 to 0.8, I agree with Ayush substantial amount of times. If it is 0.81 to 1, it's almost perfect. Like, we kind of agree as raters almost 100% of the times. Okay, so this is, let's say, one kind of a rubric that you can use to understand and help somebody understand that, like, okay, if my agreement is coming out to be 70%, what is a true agreement, and what it is something, and how much of it is something like which is coming purely because of, let's say, some random chance, right? So this is something that, like, you can use. Now, are there cases where even Cohen's kappa can go for toss? Yes, very highly likely, right? Especially, let's say, when you're looking at a lot of imbalanced data sets. And Jishan, this might be relevant for you that, like, if you're looking at a data set in case of a banking industry, especially in case of fraud, right? The fraudulent actors are very less as compared to the good actors. And hence, it's a very imbalanced data class that, like, we see in the financial data industry. So imagine, like, a scenario is coming when 95% of the responses are good and only 5% are bad, and they're genuinely good and bad responses, which means that why this data is imbalanced, because lot of responses are good and only a few set of responses are bad, right? Now, in this case, a human SME will also say that 95% things are good. Let's say I will also say, LLM will also say, like, if you have created a good LLM judge, that, like, okay, 95% things are good, right? Now, what will actually start happening is that your P, the value of P will actually start becoming very, very high. Right now, if this P ka value starts becoming very, very high, right, the Cohen's kappa ka value will actually start becoming, let's say, it will start basically showing you very, very wrong things, because this is actually becoming high. Now this is actually tending to zero. right? Now, does this mean that like I created a wrong LLM as judge? No, it is not the case. So whenever you're trying to use, let's say, coherence as kappa as a metric to figure out to tell you that like what is the judgment which is coming between LLM as judge and SME, always keep on focus upon that like what is the data set that you're looking at. If it's a very imbalanced state, coherence kappa is not the right metric, right? And in such cases, you start using something called as MCC, which is Matthews coefficient correlation. Again, we are not discussing in today's in today's session that like what is a Matthews coefficient correlation. But in case of imbalanced data sets, you should start focusing a lot upon this MCC. Now let's move on. I will hand it over to Shailesh.
Before that, want to introduce ourselves. This is our course. Like, if you are interested going into the depth, preparing for AIPM interview, vibe coding, RAG, eval, advanced eval, agentic automation, basics of starting from basics of machine learning to advanced data pipeline, prompting, pricing strategy, you can definitely opt for this one. I put the link in the description box. You can see that. Like, Apu, like, let's move forward.
Shailesh. Now we have discussed about, let's say, agreement is one of the metric, right? But let's say if you were to even create, let's say, a visual mind map of, okay, I created as an LMS judge and how good it is performing. And you have to also understand that, like, okay, if I throw in my AI system and also identify the areas where it needs to improve, how do I create, let's say, one single view where it will be also easy for me to understand where things are going good, where things are not going good, and where it will also be, let's say, very easy for my stakeholders also to understand that, like, what is going good, what is not going good, what do I do, right? So you create something called as a confusion metric, right? So this is nothing but, let's say, a 2 by 2 metric where what you start doing is that like you start plotting the human, let's say, score against the LLMS judge score, right? So typically it's a 2 by 2 metric where whatever human is basically passing, saying as yes, and LLMS judge is passing as saying as pass, comes and sits here. So typically, this is like the most happy position to be in, because if LLMS judge is also passing certain things and human score is also passing certain things, this is like the absolute, thing that you would actually want your system to behave. Like if most of the things are falling in this particular criteria, no action is needed. You are doing a very, very good job as a AI builder. In the second case, let's say, well, a lot of your responses that are actually coming out, which you are evaluating, are basically coming and sitting here, right? Where humans are saying that, like, okay, your SMEs are saying that, like, okay, it's a good enough thing for me to pass, but your LLM judge is saying that, like, no, 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 it's not a good response. This is probably one case where you need to kind of improvise your evals because your judge is becoming very, very harsh, right? Now the third case where humans are saying that no, absolutely it's a very, very bad response, but your LLMS judge is actually passing it. And a lot of your outputs are actually coming and sitting in this specific criteria. This is one area where you should start improvising your evals, because right now your eval is way, way too lenient. Okay, it's not doing the job it is supposed to do, right? And the fourth case, right, like where your human is also basically saying that, like, no, the response is bad, and LLMS judge is basically saying the response is bad. This is a case where AI system is poor, right? Maybe I'll tie it back to the point that, like, your either AI system is not even capable enough, and rather than working a lot upon evils right now, should start focusing a lot upon the AI system itself, because there's a lot of juice that you can extract if you improve it, right? And right now, there's no need to focus upon evils. First, improvise your AI systems if this is where your most of the instances are actually coming and setting. Any questions so far? Okay. Now let's talk about some of the biases, let's say, which comes in LLMs as judge. And like once we have covered this topic, we'll move to the demo part, right? The first thing is, so there are a lot of systematic biases like which can kind of impact your LLM as judge, right? So one thing, let's say, which comes into play is something called as position as bias. So LLM as judges tend to favor responses which comes higher in the order, right? So what's an example? Typical example is that if you simply ask LLM as judge that, okay, which response is better? In scenario A, when response A is coming on the top, it will say, okay, response A is better. In scenario B, let's say when response B comes on the top, it might say that response B is better. But will it happen all of the times? No. Let's try to understand, let's say, more in details, right? So let's say when in the scenario A, when the answer themselves are, so different. Let's say the question that you are asking is something where both answer and answer B are, let's say, starkly different and only one answer is correct. The position bias will not come into play. So it will start, let's say, picking the right answer itself. But if the both outputs are good, the summarization example that we have talked about earlier in the slide, and the judge needs to make a final distinction, it might so happen that the position bias might actually come into play. So to understand if your judge, let's say, has position bias also or not, what do you do is that, like, say, you try to basically use a strategy called as shuffle and compare. You try to basically switch the responses, let's say, in your, let's say, in your different outputs, and then ask LLM as judge to rate them that, like, which is a good response. In case after shuffling, the LLM as judge is also kind of shuffling the answer, which means the judge has a position bias, and you need to kind of work upon to remove that specific bias. The second thing which also comes into practice is something called as a verbosity bias, because LLMs tends to favor verbose answers irrespective of the quality. Now, let's say if we simply ask LLM as judges that, like, which response is better, and there are two responses. The first response is basically the capital of India is New Delhi. The second response is capital of India is Delhi, which is located in northern India, surrounded by the states of Haryana and UP, right? Now, though the first answer is correct, but it might so happen that because of verbosity, your LLM as judge might start favoring towards the second specific response. And this is like what should also basically keep an eye upon. If you want to kind of defeat verbosity as a bias concept, then what you can do is that, like, you can actually start mentioning, let's say, in your AI system itself, that, like, the kind of output that I want to limit it to a certain characters also. Or let's say whenever you're trying to evaluate the responses which have a length, always, let's say, put some kind of penalty if the response crosses, let's say, a certain threshold, so that, like, you're also keeping a lens that you're also penalizing the output if it is long enough, and ensuring that, like, it is not getting judged as a right output purely because of the length. Okay. So this is the overall scorecard that you can keep in mind when you're trying to kind of assess LLM as judge, that you should always try to measure your success rate with a confidence interval. Along with that, you should also try and calculate something called as Cohen's kappa, which helps you understand that, like, okay, how much of the LLM as judge is in agreement with the SME, and how much of that agreement is coming actual because of the agreement, and how much of it is just because of pure randomness. Then we also discussed about something called as confusion metrics. I think this is the most important tool that you can create, and then you can take it to different meetings that you have to showcase it, like whether it is working beautifully, whether your AI system is even working also or not. It would be a lot easier for you to even make the users understand, or make the audience understand that, like, how good the AI system also is not. And once you're creating, let's say, any kind of an LLM as judge, you should also try and keep a check that, like, whether your judge is having a position bias or whether it is actually having a verbosity bias also, right? So this is what I think, like, we had to cover in the theoretical section today. And next we will move to something which is the live demo of what we have discussed as concepts today. If there are any questions we can discuss, we can take it up right now, or else we can actually move to the demo part.
Any
For the
yes.
demo.
Yeah, okay.
Sure. Handing it over to you, Shailesh.
Yeah. Give me 1 minute. I hope, like, the screen is visible. Yeah. So, like, what we have done is, like, because we don't have the production data ready with us, we don't have, let's say, a chatbot sort of feature. So what we did is we just injected some of the input and output. So in a real world, what you would have is, like, from the events table, you can get the aggregate and, let's say, get, let's say, all the input and what is the output you are having, right? So that you will get from your, let's say, a production data. But here, what we did is, like, we are just the data which we have created as a mock data set, right? So what we did is, like, we'll just import this. First thing is we'll create a data frame so that we can tell you how to create, let's say, a code based eval, how to create, let's say, your of the model evals, right? So this is just a loading of the data in your data frame. Let it run. Yeah. So it has run, like, we have our data frame ready. Now what we will do is, like, we will go with the first level of eval. And first level of eval is, let's say, your code based eval. For that, you don't need any AI model, you don't need any, let's say, your LLM as a judge. These are, like, some of the basic use case which you want to follow. For example, let's say if you want to have the keywords or the response of LLM in a certain terms in a shopping chatbot, or if you want to get the response of a LLM in certain frame. For example, it will be very easy for a developer on a UI to get the data from the JSON, right? If your LLM or the chatbot, if whatever the LLM you have integrated in the chatbot is giving the response in terms, let's say a paragraph or the textual thing. So what then the developer has to do is like developer has to again put certain model out of it, get the phrases out of the text which the LLM has given, and then create a and then pass those phrases to, let's say, a front end mobile, so that like the user can see the let's say a good shopping bot response and everything. Right. So rather than what we can do is like if LLM itself is giving, let's say, the response in terms of JSON, it just have we have to just plug and play the keys and the values, and we'll be able to surface it, right? So this is what like it will do. Yeah, so what it has done is, let's say we have passed the mock data into, let's say, a very code base sort of this thing, and the result is coming out to be, let's say, the level one passed given to, let's say, one of the mock data, and let's say second and third is your false, right? So let's see what is how the first output is coming. The first output is coming in the JSON format. For example, particular product, like what is the product it is, what is the pricing status, so in stock, out of stock. But if you see the second one is, let's say, do you have any red boots? The output is not coming into the JSON. It's, let's say, a complete text. That is where it is giving you 0 because your code based eval is now has failed for that particular response, right? This is what a very simple example of your code based eval. Now moving on to the second one, where, let's say, the complexity has arisen a little bit, where your code based eval will not play a very important role, because there is some sort of ambiguity and probability that is coming into your response. Here what we will do is like we will utilize lot of let's say freely available AI models which has been trained over the course of last 10 to 15 years, because sentiment analysis as a problem is not a new problem, right? When Amazon started way in, let's say, 2010, 2012, right? So on their product detail page, there will always be have, let's say, what are the rating and reviews which users are giving as a positive reviews, negative reviews. Like, there's not a very new problem which is like getting solved right now. It's a very old problem. A lot of different companies, industries, there's a let's say open source models are available. So what we'll do is like we'll invoke these model as an API. So what we'll do is like we'll just let's say get those models. So what you can do is like you can let's say from the transformer, like all those library, you can invoke that. So what I have using is like I am using, let's say, text classification as a model, right? So let's see, it will take some time like to invoke all of these model, and then we'll see like what is the response we are giving. What you can do is like you can go into the library, check out, let's say, what are the models that are available, and once these models are available, you can also, let's say, in your some of your use case, you can use that, right? So this is what I have just invoked, the like from the BERT embedding, I have just invoked all of these models. What the result is looking like is, let's say, the first one, it is passed because the response which I am expecting from the let's say LLM is kind of good. But the third one, it is saying that it is not in line with the response which the chatbot should give. Let's see what is the third mock data which we have put. The third mock data is the input user said that I hate this website, it's terrible, and you are stupid. In, let's say, in the output, the LLM is saying, I'm sorry you feel that way, you idiot, I cannot help you. This is not, let's say, a very helpful chatbot, right? So the very first thing, whenever you are writing a prompt to create a chatbot, you will say that like you are a fashion chatbot, you are a, let's say, lifestyle chatbot, you are a friendly chatbot. These are like some of the consideration constraint you have to think about it. All of these prompting you would have written, right? So that is why this score of the third one is 0. That means your one of your input output data is not able to like is not adhere to what your chatbot is supposed to do. Finally, what we can do is like, how can we invoke your LLM as a judge? So like Apoor told you about how to write a prompt as a LLM as judge. What we did is like, you will just invoke, let's say, one of the model. If you're using, let's say, Gemini, or let's say any other open AI, what you can do is like, you can just invoke the model. If you have the key, you can put it out there. We have just commented it out. Then what you can do is like you can let's say give the prompt. Like here what it will happen is, let's say we are passing user input as a user question and output as a shopping bot question. And what it will do is like it will give you a response. So here we'll run. Yeah, so it has run. So what it is saying is, let's say the fourth response. So what kind of let's say evals or let's say in what case LLM as a judge will be used as an eval, where you want to see the relevance of the output. Let's say whether the output that is given by LLM as judge is a relevant output or not. For example, what it was, the fourth output is the skyline like watch waterproof, right? So the output, because it might be trained on your, let's say, Amazon chatbot, Amazon data and everything, it's an internal model there. So skyline watch answer, yes, it is a waterproof up to 50 ms, right? 50 meters. So is it let's say a relevant or the correct response? That is where your LLMS judge will come into play, right? So here it is not a waterproof, it is a water resistant watch, right? That is why it is making it as a false. Now, once you have, let's say, all of those things, once you have like LLMS judge, what we'll do is like we'll create a final metric, like all those your code-based eval, how much it is performing, let's say, based on your input. On the dimension of brand safety, let's say the AI model which we invoke from the transformer, how is it performing out of all the data sets which we have given. Then LLM as a judge, how good it is performing. Once you have that kind of score, you will know, let's say, I have used these kind of evals in my shopping bot. This is my accuracy for all of these evals. Now, finally, what we will do is, let's say here also we have just put the mock data to think about, let's say, if LLM as a judge is saying something as a good, or human rater is saying that something is good or bad. Based on that, how can you create a confusion matrix? This is what we have. You can create a confusion matrix. You can create a Cohen's and Kappa score, and then this is what ultimate reliability of your system will talk about. If LLM is also saying that, if the score of the quadrant where LLM is saying that your system is bad and your human rater is also saying that system is bad, then there is a like lot of amount of work should be needed to make your system even, let's say, capable enough to let's say perform the required output, right? Otherwise, either you can improve your evals or your system might be very perfect, right? So this is what a let's say end-to-end thing which you need to do. The only thing will change in case if you are using these kind of things in your production data is, let's say here we have used the mock data. You need to do on a real production data, you need to, let's say, do all the actual coding which we have shown. If you have to do open coding, you have to read all those traces, right? Because you cannot go away from reading the traces. You have to read the trace. That is where you will understand where my model is failing, where my model is not failing. Then from traces you get the let's say open coding, actual coding, and then you will create all those sort of evals, right? That is the first step. And then it is just putting these kind of thing into the system, and your, let's say, the evaluation report is kind of ready. And this is what it will look like in a real production also. Any question on to this? Yeah. Okay. Stop share. Like any question, anything, like we have spent around 2.5 hours. Next 15-20 minutes will be entirely on question. If you have anything, we can discuss. You have any question, any problem statement, or anything you want to understand, we can discuss it.
So I'll start. Like, thank you. It was a good session. It's just that, to be honest, like before coming, I have just known very basic of Evals. So now I have understood a bit, but this is a little bit. What actually I have now, I'm thinking is that I have to do a lot of hard work on going depth towards understanding each of the other things, right? So it is just open that direction towards me. So it was good. As of now, I don't have any question, but I do have a lot of questions when I start implementing it. So I wanted to know how can I reach out?
Yeah,
Because
you can definitely reach out. Like you can reach out to us, like Apur on me with the LinkedIn. Like It
Sure.
will always be open for all of these things, because over the last course of 2 years, we have created all of these AI systems. Like we have failed so badly. So like if you're able to add, let's say 1 or 2% in the value to your, then like it will be like we'll also feel good. Yeah.
Yes. And do you have any resources apart from this if you have to go to more depth or like some
Depth in
example?
what? Depth in, let's say, AI evals, or depth in what?
Yes, AI events itself.
Yeah, so I think like we
For
have
example,
covered.
if I would.
Yeah. So what we have done is we have covered fairly in depth. Uh, Now what it will do is like you can read n number of resources on, let's say, confusion metrics, going into the where to use, where not to use. But ultimate learning will happen when you, let's say, if you have done, let's say, vibe coding, lovable and everything. Like I would want you to go back and think about how to write evals, right? That is the number one step. So like I'm not telling you to create an eval set for, let's say, a very big, let's say, a website sort of thing. What you can do is like you can just write a very small agent or gems, if you can think about in the Gemini, right? These gems, like write a very, let's say, slightly complex gem in Gemini. Then what you should do, or let's say skill in, let's say your Anthropic, or let's say Claude, then try to give all sort of different type of mock data. Now here also the mock data you can generate with the help of Gemini itself, and try to think about where your gem is failing, where your skill is failing. That will give you a very good let's say idea of whether your skill is good or not, whether your gem is good or not, and try to plot this sort of graph where you'll understand, let's say, what are those things which I didn't think of at the first place, and now it is coming into, let's say, a mock data from the Gemini and it is failing. That will be your real learning.
Got it. Got it. Thanks, Anish. Yeah.
So, just a quick suggestion or maybe guidance towards how do we build evals for agentic scenarios, right? As you mentioned that this session is more of like for generic AI things that we build. So, are there any resources that you would suggest? So I'm particularly looking for the scenario where we don't have any any insights into the inputs, what the users are basically giving to the agent, and also towards the outputs. So I am facing a bit of challenge. I tried creating like an eval set for the same, but then there are n number of scenarios which the users can, come to the agent and ask and query, but we don't have insights into what exactly they are querying. I just have, list of things that I can put and then evaluate my agent for those particular queries. So how do we baseline and how do we see if that agent is actually working fine?
Yeah. So I'll give you a brief context about this one. Let's say the two question, like if you
Mhm.
don't have the data, and let's say for the, let's say, for the agentic workflow, there is, let's say, if it is a agentic workflow, you will have certain nodes, right? Your certain agents nodes. These are like some of the basic routing points. For example, if user input is coming from here and output is going there, from input to output, there will be certain nodes which your agent will be calling, maybe some tools. Maybe it's, if it is a multi-agentic workflow, it will call another agent as well, right?
Yeah.
So here what we do is like we'll create a transition metric. How does the transition metric look like is, if there are multiple, let's say, on the y-axis, on the x-axis, there are different agent where your agent one can call to tool, agent one can call to agent two, and then we will see for each of these transition, let's say, what is the success rate looking like. For example, there are 8 agents and they can go anywhere. So there will be a 64 8 cross 8 ka matrix you need to create, and uh, try to think about, let's say, try to fill the accuracy when these agents are calling, and try to find out those red pockets where you feel that this is the one node which is not performing that great. And now what you need to do is like ultimately go deep dive into, let's say, those kind of node. So it's just an extension of what we have, let's say, learned here. We have just created an eval for a, let's say, a single node or single thing. Now you need to create a very complex set of eval for that 8 cross 8 matrix, and then try to think about how can you improve that or not.
Got it. Okay.
So that is one thing. Second is, let's say if you don't have input, so want to understand, let's say when you say you don't have any input, when you don't have any output, what does it mean? Uh, do you
So,
not log the data, or you don't have the mock data? Like, for example, there are certain legal constraints that we are not logging the user query, like what user are typing. We are, let's say, due to end-to-end encryption or due to some legal issues, we are not storing that into our database. But uh, we can definitely create our own mock data set, right? We can create a mock data and that we can store because it's our data, and then we can perform all these analysis. So want to understand, when you say that we don't have any mock data, any data from input output, like what does it mean? What is the use case you are trying to solve?
Okay. So when I say that I don't have access to, there is a log which is maintained for all the user queries and the type of output that is generated, but we don't have access to that. So I've built like an agent on top of M365 Copilot, which is like an internal agent that helps, to answer queries, pull information from multiple resources, and then generate a summary and insights out of it. So I don't have the information of what are the different queries that the users are asking. So, for example, I have 4 different plugins. I am pulling information from, say, SharePoint. I'm pulling information from Word documents and all those things. So I will only have like list of queries that maybe standard queries like mock queries that you said, right? The mock queries or mock prompts, and then I will evaluate like what is the response that my agent is giving and what should be the correct response, like ideal response of this particular prompt, and then I will run the eval set in order to check like if it is failing, how much percentage it is failing, or it is successful or not, right? But like there are a n number of scenarios that the users basically are inputting for this SharePoints, and but I'm not able to evaluate my agent for all those scenarios because I don't have access. I don't have access to what all queries are being loaded into the agent and what is the response that the agent is giving. So this is basically a blocker for me in my current scenario where I am trying to evaluate the accuracy of the
Okay.
agent, like
What?
the response accuracy.
Yeah, so if you don't have exact query, so what other data you have? So for example, when you would have built this 365 Copilot, there will be certain use cases you would have in mind, right?
Yes.
These are the use cases which will, let's say, which your 365 will support. Can't you not create, let's say n number of scenario for each of these use cases? So one other thing is, let's say, rather than creating a mock data for entirely, why can't we break down your 365 into, let's say, 15 or 20 sub use cases, and for each of these use cases we can create a mock data, so that, let's say, currently you are covering a ground of 40%. Now, let's say, from utilizing that, you may be covering, let's say, 75% ground. Other thing can be, let's say, can you, not exact query, can you log something from that query? Maybe, let's say, the query length, the intent of the query. If it is a multi-intent query, it is failing, or a single intent query, it is failing. It is, let's say, maybe some dimension, because if you don't have any input, then it will also be, let's say, the coverage of what you would have thought of, that only will be able to improve. Apur, if you have any thought on this one.
See, I think what you're basically guiding is true, but Krishna, let's say without even understanding so I think if you have looked at the trace analysis also, right? Like it's always, let's say, an input output pair. So
Yes.
if you're not having, let's say, I think the logs to input, I think it's a difficult problem because I think without even understanding what user is asking for, right? How would you understand it? Like say, what is the right response?
Yeah.
And maybe I think in that case, you have to say go the harder way out. As Shailesh is also trying to say that, like try and figure out it, like what are the different use cases which might actually come across, and try and run multiple, scenarios of such to understand that like your product is actually working in the right shape or form also or not, right? But without having, I think, the right input output pair combination, it's going to be tricky.
Got it. Okay. Sounds good. Thanks for answering the question.
Hi, I have a question regarding multimodal LLMs. So I work mainly on image generation models. So I would like to, if you have any resources that you can share, where we giving instructions on how we can create evals for such systems, then that will be great.
Shiny, I think like we'll be honest, like say we have not delved into the topic of image-based evals right now, but let's say if we do come across, we'll share it across with you.
Thank you. Yeah, that'll be
Yeah.
great.
Okay, if we don't have any question, we can close the call. Thanks everyone for joining. Yeah, thank you.
Thank you, guys.
Thank you.